Hello.
Hello, sir.
Am I audible?
Yes, sir.
Okay. Very good evening to all of you. So, this is the session for statistics one. Okay, so session for maths one has been ended, right?
Yes, sir.
Okay. Okay. Hope you have covered the lectures of all the um, concepts of this. So, okay, so I have created PDF of questions, some collection of questions. Okay, we will go through one by one each question, and we will discuss each topics and all things. And please let me know if by chance any topic is missed out. Otherwise, we will try to cover all the things. Okay, so yeah. So how many? Okay, so this is the first question which I have taken from the week one. So please read it and tell me which one should be the correct answer and why.
C.
C
C.
is the correct.
C.
Okay.
The
Why
answer
not
is C.
first one?
Because sample is a subset of the population.
Population, right? Yeah. Yeah, you are, you guys are correct. Because see, population is the entire group, while sample is a subset of the population which is used to describe the parameters of the population. First one is wrong because see, what is the population? Suppose this is your whole population. I'm taking as this whole thing as a population. Okay. So what is the basically popular meaning of the population? Population is nothing but the total collection of all the elements in which we are interested in, right? Sample is nothing but the a subset of this population. Okay. So this is the subset which also called sample, right? And sample should be a good representative of the population also, right? So yeah. So first question is clear, right? I mean, you know what concept of sample and population. Okay. So let's move for the next question. Yeah. Please read this question carefully. And yeah, and you have to identify the. And my screen is visible to all of you, right?
Yes, sir.
Yeah. Okay. Nice. Nice. Yeah. Please read this question and tell me which one should be the correct. I mean, what is the sample and what is the population? When you read the question, just tell me. I have to scroll up so that you can see last option of the.
For 2, it's C.
No, read the question.
Oh, sorry, D.
Okay. See,
Sorry.
question is saying a study has been conducted to examine whether the students who had applied for the MA triple entrance exam in 2020 are willing to write the exam in the coming week or not, right? This is the something yesterday. Now, group of 10,000 students were randomly selected from the urban areas of India for this study, right? Now, you know what is the population? Population, the total collection of the elements in which we are interested, right? So, what is the population is urban areas of the India, right? Because we are interested in the to know the, I mean, sorry, we are interested in the students who gave the exam of MA Triple E in the 2020, those who are willing to write the exam in coming week or not, right? So we see what is the selection. Selection 10,000 students were randomly selected from the urban areas of India, right? Okay. So what is the sample? Sorry,
10,000 students.
10,000 students from the urban areas of the India, right?
Yeah.
Yes.
Now, what will be the population? Population will be the population consist of students from all
Across
India.
parts
So
of
your
India.
D is the correct. What is the population? Population is students from, see, what is your population? Population is students from across all India, right? What is the sample? Sample is
10,000 students.
10,000 randomly selected students from the urban areas of India. Okay. Now, is that clear? See why first one is not correct. First option is saying sample consists of students from across all India, but this should be the population, right? So that's why this option is incorrect. Second is sample consists of students from the urban areas of India. It says sample consists of urban students from the urban areas of India, but in our study we have selected 10,000 students, so it should be 10,000, right? And in the C option is saying population consists of 10,000, which is obviously wrong, because sample consists of the 10,000 randomly selected students. So D option is the correct one. Is that clear? I mean, this things is clear. How to choose the sample and what is population and all things.
Yes.
Okay. Now let's move for the next question. Okay. Should I? Do you want to read the question again? Because on the behalf of this question, we have three sub questions. So see, if you see in the question, it is also mentioned that it is concluded that roughly 80% of the students want to write the exam. Okay, now come to the next question. Next question is identify the correct statements from the following. What are the correct statements? First statement saying aforementioned conclusion. That means that 80% things made on the basis of the sample is correct. B is saying aforementioned conclusion is not correct because the sample is not a good representation of the population. C is saying sample is a good representation of the population. D is the none of the above. So according to you guys, which should be the correct option?
B.
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 Why not A and C?
Because B, it is only taking students from urban
Yes,
cities.
and it's not
Yeah,
taking from the
correct,
rural
correct,
area.
correct. Rural area. That's why it's correct, because see, you know, sample should be a good representative of the population, right?
Yes.
Okay. So if suppose what is population? Our population uh, is to all students across all India, right? But sample, which what we are selecting? Sample is we are selecting 10,000 students only from the urban area, right? So this is not a good representative, because see, good representative should be means 10. Suppose I have selected 10,000 students across randomly across all the India, then it will be the good representative, right? But we are doing something, you know, specific kind of things. We are not doing some best representation kind of thing. Is this clear? Why the B option is correct?
Yes.
Okay, that means you got the concept. What is the population? What is the sample, and sample should be a good representative of the population as well, right?
Yes,
You are
sir.
getting my points, right? Yeah. Just let me know when you are, you are facing any problem. Yes. So this is the fourth question. It is asking about the what can you say about the nature of the study? The study is descriptive or the study is inferential?
Descriptive
It's
study.
descriptive.
Differential.
It's inferential.
Descriptive.
Okay.
It's
Someone
inferential.
Differential.
is saying descriptive and someone is saying inferential. Okay. Let's go to let's first understand what is descriptive. What is the see? There are two major branches of statistics. Uh, there are two major branches of statistics. First one is descriptive, right? And second is inferential, right? What is descriptive statistics? See, descriptive statistics is nothing but this is a part of statistics which concerned with the description and summarization of the data, right? So, which which consists of description and summary of, or you can say summarization of the data, right? So, summarization of data means what? Anybody wants to tell?
Narrating whatever we
Second
have
step.
found out from the
Yes, I
The
can say
data which is
numerical.
already existing, and you have to just summarize that the whole data from the past sheet of data.
Mhm. See, whatever we have data, we are doing some graphical summary, some numerical summary. See, summarization of data means I can say some of the main points of the data, right? Some of the main points of the data. Main points of the data means what? See, I can calculate mean, I can calculate the mod, I can calculate the median, right? I can say suppose I'm taking the example of marks of class 10th students, right? Then I can say the average marks of the class 10th students is let's take 78, right? Okay, suppose I have marks of 40 students, right? There are 40 students in a class and I have marks of all the students. Okay, then I can calculate the average marks of all the students. Means I am summarizing the some data of marks, I mean marks data, right? I'm saying average marks is 78. I'm saying maximum marks of the students is 92 something, right? So which the data I have, I'm summarizing the some main points of that data, right? I'm describing that data. Is that clear?
Yes.
Okay. Now come to the inferential. What is the inferential? Inferential statistics is nothing but on the behalf of sample data, I'm making the conclusion about the population, right? Now, suppose there is a population of 40 students in that class, right? Now, so I'm taking the average. So let's take I'm randomly select the 7 students from that class. Okay, I have selected 7 students randomly from the 40. I mean from 40 students, right? Now, then I calculated the average marks of these 7 students, right? Suppose average marks of these 7 students is 68. Okay. So now be focused on here. I'm saying I have calculated the average marks of these 7 students as 68. After that, I'm making the conclusion or I'm drawing the inference like the average marks of whole class is 68. Then this type of study is called the inferential statistics. That means on the behalf of marks of these 7 students, if I am saying the average marks of whole class of 40 students is 68, then on the behalf of this sample data, I'm making the inference, I'm making the conclusion, I'm drawing the conclusion for the population data. then this type of study is called the inferential statistics. Is this clear?
Yes.
Okay. Now, come to the question. Yes. So now here, what is the question? Question is saying he has selected 10,000 students were randomly selected from the urban areas of India for this study. It is concluded that roughly 80% of the students want to write the exam. Then which type of study is applied here?
Inferential.
Inferential. Why inferential? On the behalf of these 10,000 students, we are making the conclusion that 80%, roughly 80% of the students want to write the exam, right?
Yes.
Yes.
Is this clear? Concept of descriptive and inferential.
Yep.
Yes, sir.
Okay. Yeah. So B option is the correct here. Okay. And one more thing, we see inferential statistics. Sorry, my writing is bad. Yeah, inferential statistics we can perform only on sample, right? Because on the behalf of this sample data, we are making the conclusion about the population data. But if you see descriptive statistics can be performed on sample data as well as on the population data. Is this clear or should I explain? Because, yeah, why? What is descriptive? Nothing but the description and summarization, right? Description and summarization of the data. If you see, suppose I have sample data, like let's take that sample data of those 7 students, right? Then I can also summarize or describe this data, right? Simply, right? I can calculate the average marks, I can calculate the minimum marks, I can calculate the maximum marks, I can plot a chart and all things. Suppose I have population data, let's take that 40 students, okay? Then I can also describe and summarize of the marks of about the marks of these 40 students. So our descriptive statistics can be performed on sample data as well as on inferential data. Sorry, can be performed on sample as well as on population. But in inferential is something on the behalf of sample data, we have to make conclusion for whole population data. So inferential statistics can be performed only on the sample. Is that clear? Is this clear for everyone?
Yes.
Yes.
Oh, yeah. So, yeah, come to the next question. So, yeah, please read this question. Karthik wants to start a soup production company for all the Indian market to analyze public preferences. He hires a team of market researchers who conduct market research in 2 states, Andhra Pradesh and Maharashtra, right? The sample research team prepares a form to collect the data, and collected data is shown in this table. Then we have to answer the sub question. First, tell me whether this sample collection is good representative or not.
No, sir.
No,
It's
sir.
only for Andhra Pradesh and Maharashtra, not
Yes.
for all India,
So,
because we want to make
yeah,
a
no,
protection for all India.
because his researcher team collects the data only from the 2 states, right? Andhra Pradesh and Maharashtra. So that's okay, if he collects the data across all the states of, I mean, all the states throughout all the India, then it will be the good representative of the population, right? Okay. So you got the concept. Yeah, I mean, there is a column of serial number, name, age, and age, which is in years, shoe material, purposes, price range, and suggestion. Okay. So first question is, which of the collected data is unstructured? So first come to what is structured data and unstructured data. Okay. So structured data, okay, unstructured data. So anybody wants to tell what is the structured data and what is the meaning of unstructured data?
Structured data will be
will be in a tabular format. As the name
Okay.
says, it will be in a structure, and unstructured
Mhm.
data will not have any format. It will be in any sentences or something.
Yeah.
The data which we
Or
get from Instagram or LinkedIn, is it it's in form of
or
unstructured
you
data?
can say YouTube comments and all things, right?
Yes, yes.
Yes.
So correct, Akshay. What is the structured data? We can also say the data which is already in predefined manner, right? In something predefined manner, okay, or in some standard format, right? And see, from the structured data, you can easily no, you can easily infer the. I mean, you can easily analyze the data. Structured data is something which is clearly defined and searchable type of data. Okay, and the structured data, you can say it's easy to search and analyze data. Easy and search analyzing data. Suppose it's in predefined manner. It's in tabular form. Okay, then suppose for this example, suppose I asked, tell me the uh, tell me the purpose of Rahul, okay, for this data. So you can easily tell the purpose of Rahul. Where is Rahul? You can easily tell the purpose of Rahul is for purchasing the shoes is formal, right? Then because this is something which is already in tabular form. Is that clear? So from the structured data, we can easily search, we can easily analyze the data, or it's clearly defined and searchable types of data. While unstructured data, it's not in some, it's not in a standard, not in predefined manner, okay? And you can say it's not in, and it's in a variety of formats, right? Not a fixed something. So like you can say YouTube comments on all things, right? Because YouTube comments is something which is not in predefined manner, which is not in standard format, right? Is this clear? What is structured data? What is unstructured data?
Yes, sir.
Okay. Now, so tell me, according to this given to question, what is which of the collected data is unstructured?
The
Suggestions.
last one.
Suggestions.
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 Why? Because see, this is not in standard format. If you see this particular column, okay, it's something variety of things, right? It's in native
Yes.
format, okay, not in predefined format, okay. So is this clear about the unstructured concept and structured concept?
Yes.
Is this clear for everyone?
Yes.
Okay, great. Yeah. Come to the next question. See, in this uh, question is we have to find the we have to I mean observe which are the cases or observations, okay. So name, Satya, Mayur, plastic, formal, and price range, okay. So I'm writing the options here: name, Satya, and what was the next option? Mayur, plastic, formal, price, okay. Mayur, formal,
Plastic.
plastic, and price range, okay. So these are the options in which you have to select which are the cases or observations, okay. So first tell me, what is the cases or observations?
Every individual person or thing that we are studying is a case.
Okay, and we can say cases is something what, a unit from which our data is collected,
Yes.
okay, a unit from which data is collected, right? Is that clear? Because this is
Yes.
something which is called cases or observation. Or one more thing, cases should be the unique, okay. It should not be repetitive kind of things. Is this clear?
Yes, sir.
Okay, and what is the variables? Intuitively we can say something, an attribute or something that varies, okay, that varies across all the units. right? Now, and one more thing, a row represent the cases, okay? In a tabular data, row represents our cases and column represents our
Variables.
variables, okay? Now, see, one more thing, you have to be careful. This is cases something what? A unit from which our data is collected, and cases must be the unique. Unique means what? It should not be something. It
There
should
should
not be
not be any
repetitive.
duplicates.
Duplicates. Right, correct. Okay. So according to this given data, tell me what should be the correct option? Which of these following
Satya
options?
Mayur.
Name, Mayur.
Satya Mayur Plastic.
Okay.
Formal also.
Name is variable. Satya, Mayur.
Okay. Someone
Yeah,
is saying
Mayur
name.
formal plastic.
Satya Mayur formal plastic is the correct option, right?
Yes.
Okay. Anybody else? Or these four options, I mean, are correct for everyone?
Only Satya and Mayur.
Satya and Mayur.
Okay. Hers, I think your name is Hers, right? Hers is saying Satya and Mayur. Anybody else?
Only formal and plastic.
Only formal and Vijay
Plastic.
is saying only formal and plastic. Okay. Anybody else?
I think it's only Satya and Mayur because those are the only ones which are unique. Formal and plastic are not unique.
Yes. If you see what I said, a case or observation is something uh, which is a unit from which our data is collected. First thing you have to be careful. Second thing, it should be the unique. If you see, Rahul is a unit from which our data is collected. Means for Rahul, we have collected his age, we have collected shoe material for him, formal, high, and what is suggestions according to him, right? So for this Rahul is a unit from which we have collected the data, and row represent the cases. Okay, so this row represent the cases. But if you see about name is not a case at all
It's a
because
variable.
name is variable because it varies across all the units. Okay, is that it? Now come to the next Satya. If you see Satya is a case because it is a unique and it is in row, and this is a unit for which our data is collected. Next, come to the Mayur. Okay, so Mayur is also case because it's unique and this is a unit from which our data is collected and it represents row. Now come to the formal. See, formal is not a case because there is some duplicates. Okay, it's repetitive. Same for plastic. Plastic is also repetitive. Now price range. Price is not a case at all because it's a variable here. Okay, and yeah, that's all about this thing. So this thing is clear.
Yes.
Had plastic not been repetitive, would it be considered as the option?
No. See. What is the issue? What is the scene? What see? What is the case? Tell me. Once. Case case is a unit from which data is collected. Okay.
Yeah.
If you see in this example, you have to be careful for which your data is collected. So suppose this is the unique, but it's not making some kind of sense. Like for plastic, you are collected the data, you are collected the name, you are collected the age. This not making kind of sense, right? So it should one thing, a case from which your data is collected, and it should be the unique. Okay. Now
Like rubber is unique, but it is also not the case, right?
where rubber is unique? No. In this, see, in this whole column, you cannot consider as a case because in this column, plastic is repetitive. If you see, leather is repetitive. Okay, all things should be unique. Then you can consider as a row because row represents your case.
Okay.
Is this clear? Okay, let me take another example. Okay, Suppose this is a student's name column. Okay, his age, marks, and states from which he is. Okay, once. Okay, state. Okay, suppose student's name is Rahul. His age is 19. Marks is, suppose, let's take 92%, and state is, let's say, Delhi. Okay, suppose there is a student Suman. Her age is let's say 22. Marks is 94%, and she is from Haryana. Okay, suppose there is a student Sumit. His marks is age is 20. Marks is 91%, and he is from, let's take, Bihar. And there is a student, let's take Manoj. His age is 21, and his marks is, let's take, 91%, and he is from Delhi. Okay. So in this data, what are the cases?
Rahul, Suman, Sumit, and Manoj.
Manoj, right? Because this is the something in each row represent cases, and this is the case for which our data is collected. For Suman, I have collected her age, I have collected about their marks, and where is okay, from which state she is. Okay, suppose there is another student Suman. Okay, her age is 21, her marks is, let's take 90%, and she is from, let's take, UP. Okay, then Rahul would be a case or not?
Yes. I think yes.
No.
Why?
Roll numbers.
Then Rahul would be a case or not?
Yes.
Not be a case.
Yes.
No.
No.
Roll number will be a case.
Roll number should be taken because it
Why
is
Rahul?
unique.
Why
Yeah,
Rahul
replicating,
will
right?
not be a case? Because suppose yeah, suppose Rahul is, you can take, you can say Rahul is one time, but suppose there is a large data. Okay, there can be Rahul repeated, but suppose for this simple data, Rahul is not case, because case says should be the unique. Okay, but if you see Suman is repetitive, that's why it's not unique. Suppose I'm asking about, tell me the state from which the Suman is, then you are not aware about I mean, this Suman I'm talking about, this Suman or this Suman, right? So if you see, now come to the roll number, then roll number is what? Roll number is a unique, right? And come to this data, suppose I am collected the data according to the roll number. So this row represent the case. Okay, similarly this row represent the case, this row represent the case, this row represent the case, this row represent the case. And if you see, roll number is unique. Suppose I'm asking, tell me the marks of roll number 2, students of roll number 2, then you can easily tell the 94%. Suppose I'm asking you, tell me the marks of Suman, then I mean, you might get confused. It should be 94 or it should be 90, right? So cases should be the unique, and all columns names is the variables, because it's varies across all the units. Is that clear for now? Cases or
Yes, sir.
variables?
Understood.
Yes.
Okay,
Yes.
understood.
Yes.
I mean, for everyone.
Can
Yes,
a
sir.
combination of two
Yes.
variable be a case, like student name and state?
Yes, sir.
It depends on your objective of data actually. Okay, what is objective of data here? Okay. Now come to the yes. So tell me, how many variables from the collected survey data are categorical? From this data, how many variables are categorical data?
Show material, purpose, price range.
Even age also can be category.
But here we have not given age as range. No.
7 variables.
Huh? Okay. Let me cover the concept of categorical and numerical data. Okay. There is two type of data: categorical data and numerical data. Now, categorical data is what? This is something which is qualitative in nature, okay, not quantitative, okay. And see, categorical data is something on which we cannot perform meaningful mathematical operation, okay. And just opposite of the categorical is numerical data is something, it's quantitative, it should be some quantity, right? Numerical data is quantitative in nature, and we can perform meaningful mathematical operation on it, right? Now, suppose I'm saying, see, categorical data can be in numbers, but we cannot perform meaningful mathematical operation, meaningful arithmetic operation. Like suppose I'm saying, tell me, a jersey number is what? Categorical data or numerical data? Jersey number of cricket players.
Numerical.
Numerical.
Why numerical?
Categorical.
Categorical.
Why numerical? See, it's in numbers like 0, 7, 11, and 17 kind of things. But since see, this is something of categories, right? It's nothing but just a labeling. Okay. There is not a meaningful mathematical operation, right? You cannot say like 11 jersey number player is good than 7 jersey number player. This is making any sense? This mathematical comparison is making any sense? Can you say a jersey number of 11 plus jersey number of say 7 is same as the jersey number of 18? Is this making any sense?
No.
No.
This is just a category, just a labeling. We cannot perform meaningful mathematical operation on this, right? Like just tell me about pin code number.
Categorical.
Why categorical? It's just a labeling for every areas, right? You cannot say the pin code of your region is greater than my region. Is this making any sense? Not.
No.
Tell me Aadhaar card number.
Categorical.
Categorical.
Just as something labeling. You cannot say my Aadhaar card number is greater than your Aadhaar card number. You cannot say Aadhaar card number of A and B is same as the Aadhaar card number of person C. I mean, this does not make any sense, right?
Yes.
Yeah.
So tell me about mobile number.
Categorical.
Categorical.
So it can be in numbers for labeling and all things, but meaningful mathematical operation we cannot perform, right? Come to the numerical. On numerical, we can perform meaningful mathematical operation. Let's take marks of the students, right? Okay. Then suppose A marks is 20 and B marks is 40. Then you can say B has received 2 times marks than A,
Yes.
right?
Right.
Yes.
And I can say average marks of these 2 students is something, right? So that
Right.
means we can perform some meaningful mathematical operation on the numerical data. Is that clear for everyone?
Yes.
Right.
Now come to that question. Now tell me, what should be the categorical data, and I mean how many categorical variables are there?
Age, shoe material, purpose, and price range.
Show
Age,
material, purpose and prices. 3.
Total 4.
Four.
Shoe material,
age, two
purpose, price.
materials, purpose, and price range, right?
Name as well. Name as
Name as that means 5, right? Anybody else? I mean,
Shoe material, purpose, price range, and suggestions.
Name cannot be.
Numerical.
why suggestion? Suggestion is not categorical
So not
variable.
age, I think.
No. Price is not a category.
Serial number is also categorical.
So
No,
only
one
shoe
more thing I want
material
to clear. See, serial
and
number is not
purpose.
a variable at all. So serial number we cannot consider as a variable. If you suppose there is not a column of serial number, then again you can consider as 1, 2, 3, 4. Okay. So serial number is not a variable at all. Now come
No,
and tell me
price
about
price range is also not categorical because we can say high, medium, low for a quantity.
no
We
Majnu.
can
No,
compare. We
see,
can compare
no.
low, medium, and high, right? We can
See,
compare between.
There are 4 categorical variables: name, sue materials, purpose, and price range. Okay. See, you are saying, Majnunath, that price range is a numerical variable. Okay.
Yeah.
Why? Can you say something high plus medium something? Right. It's a category. Okay.
Yes.
See, name is just a labeling, so it comes under the categorical data. Right. Age is numerical data. Why age you are considering as a categorical data? Age is number.
Age
Suppose,
is a numerical.
yes.
It
Suppose
is a numerical data.
Satya age is 18. Okay. Satya age is 18 and Rahul age is 37. Then you can say Rahul is, I mean, what you can say?
Younger than Satya or
Greater than or
Yeah, senior
less than.
something. And
Sir, if price would have been in numbers like 500 rupees, then it would have been numerical, right?
it would, okay. Yes. See, shoe material, there are 3 to 4 categories shoe material: leather, rubber, synthetics, plastics, foam, synthetic, plastic, something, right? Purpose is categorical variable because it has category formal, sports, and running. Price range have 3 category. One category is high, one category is medium, and one category is low. That's it. So that's why it's a these 4 are a categorical variable. Is that clear for everyone?
Yes.
Okay.
Excuse me, sir.
Yeah. Yes.
Yeah, for the large data set, can we consider name as a categorical variable?
Name is also categorical variable.
Okay. For
Because see,
large data set, can we consider that one?
yeah, whether it's large or small, it's not matter because name is what? Name is just a labeling, right?
Okay.
Name is what? Name is, suppose this is person A, this is person B, this is person C, this is person D. So I have labeled person A as Rahul, I have labeled person B as, let's say, Suman, and I have labeled person C as just Satya, and I have labeled person D as whatever, let's say, John. So this is just labeling, right? We cannot perform any meaningful mathematical operation on it, but just this is just a labeling. Similarly, gender is also a categorical variable. Okay, because there is 2 category only, male and female. Okay, so these are the categories.
Sir, but you can
Okay.
take the average, right? Like, percentage of male studying the subject, percentage of female studying the subject, so that you can make the chart out of it.
See, it's upset. See, I'm saying gender. Just tell me about gender. So if first thing, it should be on data. Second thing, I'm talking only about the gender, right? So I have 2 category, male category and female category. That's it. I have suppose some male and some female. So you cannot say like male is greater than female or female is greater than male kind of things. Okay.
Yes. Okay.
Suppose there are marks of something male and female, and you are talking about marks. That is the another thing. But I'm saying gender is a what type of variable? So gender is a categorical variable because it has 2 category, male and female. Right?
Yes, get that.
Yeah. Okay. Come to the next question. Okay, you know what is the time series data and cross-sectional data? Anybody wants to tell?
Time series data is basically over a period of time, and cross section is at that time.
Yes.
At
Time
the
series
same time.
data
Cross-section
is
is
something.
at same time.
Okay. Time series data is something which are collected, I mean, data recorded at over time, right? And this is something time series, and cross-sectional is what?
Data collected at
Data
same
is
point of
collected
time.
at the same
point
of
time.
time. Yes. Yes. Yeah, nice. So read this question and tell me what should be the correct option.
Time series data.
In order to forecast tomorrow's temperature in
Time
Mumbai,
series
the
data.
Indian department collects the temperature
It's a
immediately
time series data.
for all days from the past 3 months, because your data is collected for all days for last 3 months. Okay, so your data is recorded for the over time. That's why this is the time series data. Okay, suppose I'm interested into temperature, the to measure the temperature of different cities at on Sunday. Let's check. I'm interested in, okay, Chennai. For Chennai, let's take for Mumbai, okay, Delhi. So I'm interested in measuring the temperature of these three cities on the Sunday. Suppose Chennai temperature is on Sunday X degree Celsius, Y degree Celsius, for Delhi is Z degree Celsius. Okay. So what type of data this is?
The time series data.
Cross-sectional data.
Cross-sectional data.
Yeah, this
For all
is
cities on the
cross-section.
same day.
Yeah, because here we are collecting the data on the same day at the same time. But places are different. But if you see in the time series, time varies, places will be the same. Right? See, in this question for Mumbai, okay, data is collected for the 3 months. Okay, let's take January, for February, and for March. Okay, so your time is varying, but places are kind of same. So if your data is recorded over time, then it will be the time series data. And if the data is recorded at the same point of time, then it will be the cross-sectional data. Is that clear for everyone?
Yes, sir.
Yes, sir.
Okay. Now, come to the next question. Yeah, this is the question. Okay. So, read it and tell me what should be the correct option and why.
Ordinal.
Okay.
Yeah, it's ordinal.
Ordinal.
Okay. Anybody?
Ordinal.
Ordinal. Again, ordinal. Anybody else? See.
Is it ratio?
Why Manjunath? Why ratio? Okay.
It's
Let's
nominal,
talk
bro.
first. No, not. See. Okay, let me cover them. See, there are 4 scales of measurement. First one is nominal. Second one is ordinal. Okay. Third one is interval. And fourth one is the ratio. Okay. See, one thing you have to be careful. Nominal and ordinal scale of measurement is used for the categorical data. Okay. And nominal scale of measurement is nothing but the name categories. Okay. Here we have to do name categories without implying any order. Okay. That means there are only labeling or some name categories. For example, I can say blood group. Okay. I can say gender. Okay. I can say board of the exam, right? Like state board, CBSE board, and ICSE board, etc. So this is what this type of data comes under the nominal scale of measurement. God is nothing but just a name category, just a labeling without implying any order. See, we cannot perform any order. We cannot say perform about order of male and female, right? We cannot perform any order of blood group data, right? And what is the ordinal data? This is the nothing but the name categories or labeling something with implying order, right? That means this is also categorical data, but we can apply the order. For example, you can say feedback for a restaurant, okay, like good, better, best, or excellent kind of things. Okay, so or you can say performance of a students like excellent, poor, very poor kind of things. So such type of data we can do order. Like you can say t-shirt sizes. Okay, t-shirt sizes like small, medium, large, and extra large. So see, small is a category, medium is a category, large is a category, XL is category. So this is also categorical data, and we can we can perform order between these two. I can say small is less than, medium is less than, large is less than Excel, right? So such type of data comes under the ordinal scale of measurement, and or nominal and ordinal is used for the categorical data. Is that clear now for everyone?
Yes.
Yes, sir.
Now come to the interval and ratio. This is used for the numerical data, right? So in interval scale of measurement, see, interval between the values is expressed in terms of fixed unit. That means interval should be the fixed between two category, and we can perform addition and subtraction on the interval data, right? Also, there is one property, it should be no absolute zero. Okay, what is the meaning of absolute zero? Meaning of absolute zero means, suppose I'm saying zero number of pen, that means absence of that pen, means a zero, absolute zero means absence of that the things. Okay, so in a ratio there are, we can perform addition, we can perform subtraction, we can perform multiplication, we can perform division also with the basic property absolute zero. For interval, I can say, for example, temperature. Okay, temperature in degree Celsius. Suppose I'm saying 0 degrees Celsius. Okay, so 0 degrees Celsius, is this making sense? Like there is no temperature. Can we say? Hello? No, we can't say. If there is 0 degrees Celsius temperature, that means there is some temperature also, right? And
Yes.
it can goes in negative, like -1 degree Celsius, making sense, -2 degrees Celsius, making sense, right? So one important thing you can remember, if the values can go in negative, then it will be the interval scale of measurement, right? For the ratio scale of measurement, there is a property of absolute zero, and we can perform multiplication and division as well. Let's take example of marks. Okay, so marks of let's say student A is 20 and B is 40, right? One more thing, let me cover. Suppose, you know, the lower limit of in degrees Celsius, I think -273, right? If I'm not wrong.
Yes, Kelvin.
Yeah, okay. Yeah. So suppose this is the 20 degrees Celsius temperature here, and this is, suppose this is the 40 degree, right? So can you say distance between these two is, from this to this is, and suppose this is the distance. This is the, suppose this is distance B, this is distance A. So can you say B is the 2 times of A for this one?
No.
Can we say?
No.
No.
We can't say, right? Because
Yes.
here ratio does not make sense. Suppose this is the 0 degree Celsius. Okay, it cannot take in negative. Then I can say B is as 2 times of A.
Yes.
Yes.
Okay? That means if there is no absolute zero, then it's a interval scale of measurement. If it's absolute zero, then it's a ratio scale of measurement. Is that clear?
Yes.
Yes.
So this is marks. This is 20 marks, and this is the 40 marks. Okay, and this is the minimum marks of zero. Okay, then this is marks of the students A. This is marks of the students B. So here I can easily say B is the 2 times of A,
Yes.
because there is no absolute zero. Sorry, there is absolute zero.
Yes.
Is that clear now for everyone?
Yes, sir.
Okay, suppose marks goes in negative, there is some minus marking thing, then will it be ratio or interval?
Interval.
Interval, because marks in negative, suppose a student marks is -2 and a student marks is 0, then 0 is making sense, right? As well, it goes in negative. So from this line, I mean, hope it's easy to understand between difference between interval and ratio, right?
Yes, sir.
Okay, now come to the question. Now, which, see, ordinal scale of measurement will be applied here, because see, customers feedback is the categorical data, but here is order. I can order not satisfied, somewhat satisfied, neutral, satisfied, and very satisfied, right? Not satisfied, then somewhat satisfied, then neutral, then satisfied, then very satisfied. So I can order the thing. So that's why ordinal scale of measurement is applied. Is that clear?
Yes.
Okay. Now, so hope I think we have covered all the topics of week 1. Okay. I think we have covered, right? Yes.
Yes.
Sir,
Yeah. Yes, please.
I have one question.
Yeah.
Now,
Yes, please. Go ahead.
in general, in surveys, they would ask on a scale of 1 to 5, how satisfied were you with the product or something like that. So
See,
in that case, like
okay.
people can say 1, 2, 3, 4, 5, anything. So would this be considered numerical or categorical?
No, see, if you are doing something here, if rating is given as starting from 1, 2, 3, 4, and 5, then I think it's interval. Why? See, you difference between each unit is as a fixed. Difference between this to this is 1, this to this is 1, this to this is 1, this to this is 1.
So this is numerical.
Yes.
This is something, yes. So because see, if
Not
rating is
categorical.
given from
Okay.
1, 2, 3, 4, 5, then it's okay.
Interval.
Yeah, it's interval. Is that clear?
Yes.
But broader category
come
would
to
be
the week-
categorical,
One
right?
question.
Sorry.
The broader category would be categorical only, no?
Broader category means what?
Interval is a subcategory of categorical data, right?
No,
Subcategory.
it's of
I'm not getting the
numerical
point,
data.
Manjuna,
Interval is of
actually.
numerical data, and
You were
there is
saying, no, sir, earlier that
Hmm.
nominal and ordinal fall under categorical, interval and
Yes.
ratio fall under numerical. So they're asking if it is interval, it automatically means numerical.
Yes, see, yes. See, because
numerical, I guess.
in interval scale of measurement and in ratio scale of measurement, we can perform addition, subtraction, and kind of things, right?
But Prashant, how it makes sense that you just add 1 plus 2 is equal to 3 and something like that in case
Yes,
of these ratings?
actually categorical data. So 1, 2, 3, 4, 5. If we are numbering the
See,
we
I
are
think
creating
there was a question in activity. Where it was? See, meanwhile, I want to clarify. If suppose it's clearly mentioned, I mean there is some clarification like not satisfied is labeling as 0, somewhat satisfied is labeled as 1, neutral is labeled as 2, satisfied is labeled as 3, very satisfied labeled as 4. Then this is comes under the ordinal. Are you getting? Because we have just labeled the all the category, right?
Yes.
So such type of things
So
comes
naturally, we
under
are
the
talking about numerical data.
no, it comes under the ordinal.
But you said ordinal and
No. See, I actually I got confused. If one second, there was example. Let me search that. Anybody of have remembered that example? There was a question. I
we
don't know
don't
where it
have
was
those
in.
activity questions.
Okay, you do not have questions, right? Okay, I think I need to search that question. Okay, I will search that question. Actually, that question was like it was something rating was started from 1, 2, 3, 4, and
Yes.
5. Some numerical things was there.
Lecture, sir. This thing was also even in a lecture that this was
Uh-huh.
given, and the explanation was that this does not comes under the numerical. It comes under the categorical data. If
In which lecture it was?
I don't remember exactly the lecture, but ma'am had explained this.
Okay.
I
Okay,
think
I will start.
that's when it is explained as categorical, like high, medium, very high. So then we cannot do average between high or very high. But in this case, it's a numerical value. We can do average.
Abhijit, listen to me. What I said. See, actually, I will search that example, and there was a particular example in that scenario. It was making interval. I will search, and we will explain that in the there is another session. Okay, but till now, if be careful, if it's mentioned like not satisfied is label at 0. Okay, and somewhat satisfied is labeled as 1, neutral is labeled as 2, satisfied there is meaning. If you know, if you put it as 1, then you know its meaning is somewhat unsatisfied. And labeling for neutral is 2. Okay, labeling for satisfied is 3, labeling for very satisfied is 4. Then it's come under the ordinal, because this is categorical data and you labeled these categories, and it comes under the ordinal scale of measurement. Now this thing is clear to all of you?
Yes, sir.
Yes,
Okay,
sir.
that particular example I will search and will let you know why this is comes under the interlock. Okay, I will search that question. Okay, okay, I mean we'll tell you in the next session. Is that okay?
Sure, sure, sure.
Okay.
Thank you so
Yeah,
much.
I mean till this point you got the concept of week 1. I mean all the concept of week 1.
Yes.
Yes, sir.
Yeah, okay, okay, let's move for the week 2 questions. Okay, you know concept of in week 2 we established frequency distributions and all things. Anybody what is the meaning of frequency?
No, occurrence of a
Number of times you collect
Yeah.
data.
I collected data, like suppose A, B, A, C, C. Then frequency for A is 3, B for 1, and C for 2. So this is something, and I perform in the table. Then there is something called the frequency distribution of the categorical data. Is this clear? Now, you know what is the relative frequency?
Yeah, if we normalize it to 1, all the total normalize it to 1, how much is it? What percentage does it form out of that? So what is the decimal contribution?
Observations.
Relative to the total frequency. A particular case relative to the total frequency.
It's a total number of observation and
Yeah, I'm
comparing.
writing as RFI, means relative frequency of ith data. So this is nothing but the frequency of that data divided by total number of the observations, right? For A it was 2, for B it was 1. I think A for A, and for C it was 2. So what will the relative frequency for A? First off, tell me what is total number of observations? 3, 1, 2. That means 6 is okay. So what will the relative frequency for A? 3 by
0.5.
for B 1 by 6.
1 by 6, yeah.
And for C 2 by
1
6,
by
right?
3. Oh.
2 by
Yeah, and one more thing. See, we are you know, sum of all the relative frequencies should be 1, and you know, sum of all the frequencies nothing but the total number of observations.
Yes.
Okay, so you have concept of relative frequency. You know, sum of all the frequencies is equal to the total number of observations, and you know, sum of all the relative frequency is 1. So this is the data which is given to you. So tell me how many deaths happened in city hospital in 2019. So kindly calculate it, and you have 4 options. So just tell me which option should be the correct, and you have to apply those concepts.
It would be 1,000.
Okay, let's compute for everyone. Okay, someone said, who said 1,000?
Ranjani, me.
Okay, okay, Ranjani.
Yes, 1,000.
Okay, 1,000. Okay, and anybody else?
Data insufficient.
Data insufficient.
Data is insufficient. Sorry?
1,000, sir.
1,000. Okay. Some people are posting on the chat 1,000. See, what is this? This is the frequency column. That means for cancer there is a 150%, for accident X percent, Y percent 250, and others are 300, right? And this is the column of relative frequency. Okay, now come to the question. What is the question? How many deaths happened in the city hospital in 2019? See, How many days? That means you have to calculate the total number of days, right? Is that clear? Now, Ranjani, tell me, how did you solve this question?
Yes, so the thing is, I just use that, 300 is forming 0.3% of the 0.3 of the whole population, of the whole number of deaths. So if the number of deaths totally is equal to A, for example, 0.3 of A is equal to 300. So I get it as 1000.
Yes, this is the correct one. Because see, we have given the relative frequency and frequency. Relative frequency for ith observation is nothing but the frequency of that observation divided by total number of observation, right? So you can take any one, you can take this one, you can take this one, because the full observation, I mean, full information is the given for these two. Okay, so can I write n is same as the frequency divided by the relative frequency? Can I say or not? Okay, let's take the others example. Okay, so for others, your frequency is 300 and relative frequency is 0.3. If you calculate it, it will come out to be 1000. So total number of deaths is 1000. Is that clear? You can also compute from this. That means this example. So n is as frequency divided by relative frequency of ith. Ith means, see, ith means this one, it can be this one, it can be this one, it can be this one. Okay, so for this it is 250 and for this is 0.25. If you solve it, it will give to you 1000. So is that clear now? How you can manipulate, by some manipulation of the formula, you can calculate the question. Is that clear?
Yes.
Is that clear for everyone, right? Now, in the next question, you have to compute the value of z. Okay. So this is your
0.125. 0.125.
Okay, okay.
0.125.
भर दिया है, IIT वाली क्लास चल रही है.
Oh, is this man? Say, please mute yourself who has not. Okay, not in doubt. See, for computing z, we must know the value of
Right.
t. First
Yes,
t.
T.
I mean, first we need
0.15.
to. Okay, so for
Yes.
t, let me erase some values. I can erase, right? Or should I go on another page? Just tell me. So see, now first I need to compute the value of t. Okay, so t is what? Relative frequency. Relative frequency will be frequency upon total number of observation. So total number of frequency is what? 150, right? Total number of observation is 1000. So it got cancelled out. 0.15 is the relative frequency of the t. That means 0.15 is there, right? Now you can directly compute here. Sum of all relative frequency is what? 1. Okay. Relative frequency of this, relative frequency of this, relative frequency of this, relative frequency of this. So can I calculate z? That means I can write 0.15 plus 0.175 plus z plus 0.25 plus 0.3 as 1.
Yes.
Right? From here you can compute the value of z, which is coming out to be 0.125. Is that clear for everyone?
Yes.
Suppose I'm asking the value of y, then how can you compute? Value of z, right? Then here you have relative frequency, you have total number of observation as 1000, then you can compute the frequency.
0.125 into 1000.
125.
Okay, so 125 will be value for y. What will be the value for x? See, here given for value 175, or you can compute it like 150 plus x plus 125 plus 250 plus 300 equal to 1000 also. So by this formula you can also compute, because sum of all the frequency is equal to the total number of observations. Is that clear for everyone?
Yes, sir.
Now come to this question. When you can use bar chart and when you can use pie chart?
Yes.
bar chart when you can use? When we are interested in count of the categories, right? And pie chart we can use when we are interested in share of parts of whole, right? When there are something whole, like you can take as example of sales of items in a particular in a manufacturing company. Suppose there are 4 items A, B, and C and D. You want to the years percentage of sales of all the 4 products in the year 2022. Then you can use the pie chart, right? How much share is from A product, how much sales, sorry, how much sales from product A, how much sales from product B, how much sales. So some kind of things. So is this clear? I mean, what I'm trying to say, is this clear?
Yes, yes.
And what is the Pareto chart? Pareto chart is nothing but when you have ordered the frequencies in ascending or descending order, right?
Yes.
Let me suppose there is a bar chart. Okay, suppose some frequency is given, and suppose there is category A. This is, let's take 15, 0, 10, 15. This, let's take as 15. This is 20. Suppose this is the 18 for B, 10 for C, okay, and D for 20. Okay? Now, so this is something bar chart. Okay, suppose I'm interested in the count of the product A, count of the product B, and count of the product C, and count of. So what will be the Pareto's for chart for this? I can do for D, then
D, B, A, C.
A, C.
A and
C.
C. And reverse I can do. I mean, I can plot the Pareto chart in ascending order as well, right?
C, A,
So,
B, D.
So Pareto chart is something where we have to sorted the frequency, right? And one more thing, you know, if your data is ordinal, okay, then order must be preserved, right? That is the best practice to use. Order must be preserved means, suppose your data is something. This is a small size t-shirt, this is medium size t-shirt, this is large size t-shirt, this is extra size t-shirt. Then you have to plot the bar chart in this order: small, then medium, then large, and then XL, right? Not, you cannot say like then first medium, then small, then large, and XL. Order must be preserved. You can do the reverse: XL, large, medium, and small, but order should be the preserved. That is the best practice for the ordinal. Is this clear? You got the concept for this, right?
Yes,
Yes,
sir.
sir.
Now,
So
yeah,
this is,
come to this.
so Prasad,
Yeah,
this is for your bar chart or Pareto chart as well.
no, Pareto chart is nothing but the ascending or descending order of the frequencies. If you
Okay.
see, if you arrange in frequencies, then it will be what? It will be XL, it will be medium, it will be small, and it will be large. Then it does not make, I mean, it's not a best practice. Okay. If data is ordinal, then you order must be preserved. You got first would be small, then medium, then large, then XL. Reverse can be there: XL, then large, then medium, then small. But order should be there. If it's not some ordinal data, it's just a nominal data and bar chart there, then you can plot any. Okay. So this is the question. So please read it, and after that I will show you the options. After read the question, just tell me which charts will you use.
So bar chart.
Bar chart.
Why bar chart?
Pie chart.
Because we are not
Looking for the absolute number here.
Yeah, we are interested in revenues of the various companies, okay, using the graphs. Then it's saying a pie chart with a pie of slices for each company and with corresponding to its revenue in crore rupees, right? Okay. There are 2 examples. I mean, there are 3 more options. So just tell me which should be the correct options.
B and C, sir.
Manjunath is saying B and C. Anybody else?
B and C.
Again B and C. Okay. Anybody?
A and D.
A and
D.
okay. Why A and B?
A and D.
B and C. Yeah.
B and C. So first of the first things we are here. We are interested in some count of things, right? Revenues of various companies, right? Let's take this is company A, this is company B, this is company C. So let's take 0 crore rupees, 1 crore rupees, 2 crore rupees, and 3 crore rupees. Just a hypothetical example. Okay. Suppose for company A it's 2, for company B it's 1, and for company C is 3. So I can do by the bar chart, right? This type of things, right? And in the B option, if you see pie chart is best practice when we are in, see, if you see, you can also do, you can also plot the pie chart, but what is the question? Most appropriate. We are interested in best practice. So for count of something, most appropriate chart is bar chart. Is that clear? So if you can do this is x-axis, this is y-axis, okay? See, company on x-axis and revenues on the y-axis. You can reverse also. Company on y-axis and crore in x-axis. See, what is D? D is saying a bar chart with the minimum revenue as a baseline. Minimum revenue is what? See, if it's not a 0, then it will be a missing baseline. Are you getting my point? So
Yeah,
this option is not a
it will
fixed.
show the value as there will be no length in the bar chart, so that will mislead if it is option D.
Yeah. So is that clear? B and C is correct one. It's most appropriate for this particular example.
In a bar chart, we can have both the horizontal and vertical orientation, right? So both of them can
You
be
can do.
considered. Okay.
You can do reverse also, right? Yeah.
Okay, great.
Okay. Yeah. Now this is the other example. Which of the following can be defined for both nominal and ordinal data?
Median.
Median.
Okay. Who said median?
Mode also, sir.
Okay.
Mode. Median and mode.
I guess
Okay.
all the
Okay. Someone is said all the above. Who said?
Sir, all the above.
Rupal is also saying all the above. Okay. There are two. Sorry. Akshaya is said mod alone. Okay. This is for the Akshaya mod alone. Okay.
Mode alone.
Anybody else?
Sir, mode alone.
Mode alone.
Mod alone. Okay. Yeah. See, mod is the only thing which can be defined both for nominal and ordinal data. Why? See, just tell me, suppose this is your categorical data. First of all, see, can you compute mean for a categorical data? I mean, nominal or ordinal data? We cannot. This option is automatically wrong.
Yes.
Okay. Suppose you have categorical data, something A, B, C, A, and no. Okay, let me take another example. Let's take short size, small, large, medium, and small. Okay. So one more thing I can take as a small. Okay. So this is the something categorical data. And one more example. Let's take that example A, B, C, A, and B. So tell me, what is the mode of this data?
A.
A. What is the median for this data?
You don't know that because you don't know which one is ascending or descending.
This is not a
Cannot define the median for
okay.
this.
We cannot define the median, right? Because median is something for which we need to arrange the data in ascending or descending order. So this is nothing but this is just a nominal kind of data, and for nominal data we cannot order. That's why median cannot be computed for the nominal data. Is that clear? But you can compute mod, right? So for similarly, tell me for this data, what is the mod?
Yes.
S is the
Yes.
mod. And what is the median? First, I need to arrange in ascending order, right?
S is the median.
So S is the median most observation. So I can compute the median for the ordinal data, and I can compute mod for nominal as well as for ordinal data. Is that clear? What is the median and what is the mod? We cannot compute mean because mean is something which is used for numerical data. Okay. Is this clear for everyone, right?
Yes.
Okay. And one more thing, suppose there is something A, B, C, A, B, and B. Then what type of this data is? I mean, what are mods?
This is
A and B,
nominal data.
and A and B are mods because
Both are
this
appearing
is three
thrice.
times. Yeah, that means this type of data is called the bimodal. Okay, suppose there are more than two mods, then it will be multimodal. Is that clear?
Yes, sir.
Okay, is this clear for everyone, right? Now, come to the next question. Yeah, this is the question, something Indian telecom market. Okay, and one more thing, from bar chart, how can you find the mod?
The tallest length, the tallest
The
bar.
longest bar, yeah, the longest bar will show you the mod. Similarly, for
Bar
this
will give the
example,
mod.
what is the mod?
Excel.
Okay, mod is 20 or mod is Excel?
Excel.
Excel, Excel.
Excel is the mod because Excel occurs 20 times, right? So sometimes I mean people got confused. 20 is the mod. No, Excel is the mod because Excel occurs more frequency. Is that clear? Okay, that means longest bar in the bar chart. And in Pareto chart, the first bar in the descending order of the Pareto chart will be your mod, right? And in ascending order of the Pareto chart, last bar will be the mod. Is that clear?
Yes.
Yes.
Okay, now. Okay, yeah, this one is the question. I mean, you can see this is the
So
something.
Prashant, just
share
before Prashant, Naresh this side. So can we
Yeah, yes,
draw a
please.
Pareto chart for just like in bar chart, we can draw it either horizontally or vertically. Can we draw Pareto chart like that only, or just
Yes.
just vertically?
No. Yeah, you can draw for. Suppose this is Excel, right? I can do like this. Okay. Then large will be there. I can plot kind of this. Okay. Similarly for medium, you can do. I mean, in both cases.
Both.
Is that clear, Naresh?
Clear, Prashant?
Yeah. Okay. Okay. Thank you. Okay. So this is the some question. I mean, this is the one question. This is the share of Indian share. So we have used the pie chart. Okay. Of Indian telecom market is plotted as the pie chart shown in the following figure. So we have to choose the correct options. Okay, these are the some options. So tell me which should be the correct options. I mean, more than one option can be correct in this example.
A and E.
A and E, yeah, A and E.
A and E.
A and
Okay.
E.
Okay, again A and E.
A
One
and
more
E.
vote. Sorry, A and
A and E.
A and E.
A and D. Okay.
A and E.
A and D. Okay. Yeah. Yes. A and D is the correct. What is the misleading graph and what is the round of errors in pie chart?
If The count is
Round off,
greater than
yeah.
100, it is
Yes, round
misleading.
off error is, suppose this is something initially, suppose this is something 26.9, this is something 9.8, and this is something 27.9, this is something 37.8. Okay, if you round off, so I can do like 27, I can round off as 10, I can round off as 28, I can round off as 39. If you add, then it will be 39 plus 28. It will be, I think, what come out to be. So it is 39.
4% more, 104%.
And
It's yeah, it's a 102 is coming out to be, right? So round off error means if you round off the values and after rounding off it's coming out to be more than 100, then this such type of error is called the round off error, right? And if it's pie chart, then sum of all the slices should be add up to 100%, right? This is the something property. And area principle says, suppose instead of this 27%, this is writing this written as 37%, this is written as 27%. Then it calls area, misleading graph. Something area principle is not followed, right? Because 27 slice of 27% is more than 37%, right?
Yes.
Are you getting what I'm trying to say? Suppose instead of this 27, it is 37 and this is 27. So this is misleading. Area principle is not followed here, right?
Yes.
Correct.
Okay. Is that clear?
Yes.
So for this example, and what is the mod for the in pie chart?
Zero. Maximum area.
Yeah, widest slice. Okay, widest slice in pie chart
Reliance Jio.
Is equal to mod. Okay, so Reliance Jio is the mod for this example, and longest bar in the bar chart is we can consider as a mod. So see, this pie chart is not a misleading graph because all the, if you add, then it's coming out to be 100%. This option is not correct, and this pie charts error also has not a round of error, and this is not a misleading graph because if you see percentage and area principle is followed here, right? There is no error regarding the area principle. That means 27% is slice of 20% is less than the slices, by I'm talking of in terms of widest of the slices. Okay, so is that clear for everyone? And model Reliance,
Yes,
is
yes.
this clear for everyone? What are major errors in pie chart and kind of
Yes,
right?
yes.
Yeah. Okay, this is yeah, A and E is the correct option. This is another question. Okay. Okay, so you have to find the bar chart is given figure is misleading because you have to find the reason why it is misleading.
B.
It's option D, it's not misleading.
Option B.
B.
It's
Okay.
B.
Option B.
B.
Baseline
Okay.
does not start at 0.
Option B.
Okay, who said D?
Not start at 0.
Tell me, please. Someone said B, right?
It's B because it starts from 20.
Does not
Yes.
starts with 0.
Yeah. See, this bar graph is misleading because your bar, this baseline doesn't not start at 0. That's why it's a missing baseline. See, subjects are not in arranging alphabetical order. This is not something making sense. Bar chart are not arranged in increasing or descending order. It's not something sense. It's not a region. Bar chart is not misleading graph. This is not a correct option because this is not started from a baseline. Manipulated y-axis is not there. Manipulated y-axis is something. Suppose, yeah, let's assume. Suppose this bar chart is, I'm erasing this. Okay. Suppose this is not there. Suppose this is your y-axis. Okay, and this is your 0. This is, suppose this is your 10, and this is again, let's take 55, then 65, then 75. Then this is what? There is some manipulation in the y-axis because initially there was a range of 0 to 10, but there is some manipulation. After that, it jump up to 55. Are you getting my point? Are you getting my point? So such type of manipulation is called the manipulated y-axis. Is this clear?
Yes.
Now,
Yes, sir.
suppose instead of this, suppose this is something. Okay. Suppose. Okay. Do not consider this value right now. I'm taking an example. Oh, sorry. Yeah, 1 second, please. Suppose this is 0. This is something 10. Let's take this is some 50, 60, 70. So this is manipulated y-axis or not? Suppose here is 10.
Yes, because you're using the sign between 0 and 50 to show that.
So it is manipulated y-axis?
Yes, yes.
Okay, anybody else? Will it be manipulated y-axis or not?
Yes.
It's not manipulated because there is a symbol gives that there
Yes,
is a
Abhijit, you are right. This is not a manipulated y-axis because I'm showing there is break, right? Suppose break is for each bar. Okay, I'm showing there is a break. There is some manipulation is there. I mean, I'm showing that break. After that is 0 to 10, then jump to the 50. Then it's not a manipulation. If it's not showing it directly, then there is a manipulated y-axis. You got the difference? Is it clear for everyone? Okay.
Yes, sir.
Okay. Yeah. So that's all about week 1 and week 2. I hope we have covered all the concept of week 1 and week 2. Okay. Is that clear for everyone, right?
Yes.
Yes, sir.
Okay. Now we will start now from week 3, right? So tell me, in till week 2, we have covered about categorical data, relative frequencies for categorical data and all things, bar chart, pie chart, and nominal scales of measurement, a lot of things, right? In week 3, we will deal with the numerical data. Okay. See, your data has 2 types, right? First one is what?
Discrete and continuous.
Categorical data, right? And second one is numerical data. Numerical data. This numerical data has 2 types: discrete numerical data and
Continuous.
Continuous.
So tell me, what is the discrete data?
Individually
How can you
separate.
identify this variable is discrete?
Those take countable values.
This involves counting, right? And it can take distinct value on real number line, right? And what is the continuous?
Uncountable values.
Interval.
Uncountable, and there is some measurement,
Measuring.
right? Right, measuring is involved, right? Now, for example, tell me, okay, tell me, I'm taking example, number of road accident in a month, okay, in a particular city. So what type of this?
Discrete.
Discrete. Why discrete?
Because you can
Because
count
individually
it.
separate.
Yeah,
Counting.
we can count like 3 accident, 4 accident, 14 accident, 0 accident, right? And I can plot on discrete, then it can take distinct value, right? 3, 4, suppose 14 is there. So discrete data involves, discrete variables involves counting of things, right? Suppose I'm saying speed of a car in kilometer per hour. So what will be this? Discrete or numerical? Sorry, continuous.
Continuous.
Why
Continuous.
continuous?
Because it can have
It's
any
continuous.
value between a certain interval, like if it's 100.1, 100.2,
Yes,
Because the speed can take any value.
Also, it's a
it
measurement.
can take any value between given interval, as well as we cannot, I mean, this is not making any sense, like speed of car we are counting, we are measuring, because speed we can measure in kilometer per hour. Is that clear?
Yes.
Okay, tell me about height of a person.
Continuous.
Why continuous?
I can measure.
Can be any between any
Yes,
range.
it can take any values. And one more thing, one important property, height we cannot count, we can measure in centimeter, we can measure in feet. Okay, height is something we have to measure, this is not something we have to count. Is that clear? Centimeter or feet. Okay, weight of a person.
Same, continuous.
Again, continuous.
Continuous. Suppose I'm saying number of languages spoken by a person.
It's a discrete.
Discrete, right. Suppose I'm saying time taken by a student for writing an exam.
Continuous.
Continuous.
Because suppose their exam of 3 hours, then student can take, it can take any value between from 1 to 3 hours, right? I mean 0 to 3 hours. Okay, it can 1 hour 2 minutes 3 second and some nanosecond. Okay, so is that clear concept of discrete and continuous, right?
Yes.
And hope you are able to understand my writing. Actually,
Yes.
you are able to understand, right?
Yes, sir.
Yeah.
Yes, sir.
Yeah, okay, nice. Okay, nice. Then move further. Now, suppose you have a histogram, that type of this is for the continuous data. Okay, so we can define the intervals kind of this, right?
Yes.
And can you tell me how can you calculate what is the class mark? How can you tell me the class mark?
It's A plus B by 2.
A plus B by 2. Suppose class width.
B minus A.
Okay, it's B minus A, or suppose there is another interval C or D, so it will be C minus A.
It will be for every interval. So it is B minus A is equal to D minus C.
Actually, what is the definition between for the class width? Is the difference between
the minimum and the
lower limit of a class and the lower limit of the next higher class. Because suppose this is your, okay, this is A, B, okay. Suppose this is the C, this is the D, this is the E, this is the something else. This is the G. I think I'm doing some mistake here. I think this is A to B, right? Yeah, one second, please. No, I think B or C should be there, right? Something. It should be B or C, right?
Yes, sir.
Right? Yeah, it should be B or C.
Yes.
Yeah. So what is the what is this? It should be this is how we see what is the concept basically. Class width nothing but this B minus this A. Actually, because this is the open interval, so from where we are not considering this B initially. See, mainly it's B minus A, but what is the concept? Lower limit of a class minus, I mean, lower limit of the next higher class. Okay, see, lower limit of a class, this is what? A. Lower limit of next higher class is what? B, right? So it's by concept, it's meaning of a class width is this things minus this. Is that clear? You can directly you can compute this B minus A, but it's open interval, so we are not considering this. Is that clear?
Yes, sir.
Okay, now come to the next. Now, there was something, yes, stem and leaf plot, right? Okay.
Yes.
Yeah, this is suppose your stem, this is your suppose leaf. So 1, 2, 0, 3, 2, 3, 0. So can you tell me what is the mod of this data?
Modulus of the data. Modulus, I mean, you mean the mode of the data?
Yeah, mod of the data.
2. No.
2?
You have to convert it into range.
Actually, here 41 is appearing twice, but in a stem and leaf plot, that the leaf should not appear more than once.
No, you can't say like.
Yeah,
Suppose
okay.
I'm saying.
Huh.
Okay, suppose I'm saying meaning of 4 given 1 is a 41, right?
Correct.
So what is the meaning of here? Your observation is 12. No, it's not should be 0. 0 should be here. It's your observation because stem and leaf plot is always in ascending order, right? Your observation is 10, 12 and 13. Okay, 30, 31 and 32. 41, 41 and 42.
Okay,
This
so
is something.
leaf can be repeated also. We can do like
Yes.
Okay.
You can do. See, key observation will be there, right? The meaning of this all observations should be one line. Actually, this will be something. I mean, let me draw here. This is stem. Suppose this is a leaf. Okay, 1, 0, 2, 3, 2, 3, 0, 1, 2, and 4, 1. So key is something. 4, 1 means 40. Okay, so mod of this data is 41. Okay, you can also compute the median, right? Suppose I'm saying, tell me the observation for the stem 2.
There is no value which is beginning with 2.
There is no value.
No value.
Suppose I'm saying calculate the average of this data, then you cannot compute like 10, 12 plus 13 plus 20. You cannot 0 because there is observation missing from 0 to 9. Okay, there is no observation from 20 to 29 because for the next stem it started from the 30. Okay, so there are, I mean, it's clear.
Yes.
Okay, now come to the measure of central tendency, mean, median, and mod, right? So mean is, how can you compute the mean? Mean is nothing but the sum of the observations divided by the number of the observation, right? Yeah, I am taking as capital N, so it can be small n also. Suppose frequency is given to you, then you can compute the mean summation fi xi divided by summation of fi, right? And you know sum of all the frequencies is equal to nothing but the capital N. Okay, is that clear?
Yes.
Suppose you have given continuous data, then how you can compute the mean? Suppose your class interval is given 10 to 20, 20 to 30, 30 to 40, 40 to 50. Then frequency is given to you like 2, 3, 5, 7. Then how can you compute the mean? Then first you have to compute the mean value for this
class
right?
mark.
Class mark, right? You have to compute the class mark for class in each class interval. It will be 15, it will be 25, it will be 35, it will be 45. Okay.
Yes.
Then after that you have to compute the mi into fi, right? That means this value into this value 30, this value into this value 75. Similarly for this, for this. So what will be the formula for this? It will be summation of mifi divided by summation of
fi.
Is that clear?
Yes.
For everyone?
Correct.
Okay, now suppose we have observations 1, 2, 3, 4, and 5, right? Then what will be the mean of this data?
1 plus
9,
2 plus 2
3,
plus 4 plus 5 divided by 5.
15 by 5, that means 3 is the mean of the data. Okay.
Yeah.
Suppose I have add a constant 2 in all the observations. This will be 3, this will become 4, this will become 5, this will become 6, then this will become 7. What will be the mean for this new data?
3 plus 1. 3
5.
plus
It will be 4, 3, 7 plus 12, 12, 6, 18, 18, 7, 25 divided by 5. So mean is 5. Okay. So suppose this is your xi observations, this your yi observation, new data set. I have add a constant as a C2. So see, this is the small data. Then you can add a constant to all the observation and you can compute the mean. See, what is the property? I can write 3 plus 2. That means old mean plus that constant. Is that clear?
Yes.
That means, see, suppose you have large data and I'm saying you have to add a constant C to all the observation, then what will be your new mean? Then for you, suppose you have large data, then you are, how you can do manually and all things, right? Then there is a property, your new mean will be old mean plus that constant. That's it. That's I'm trying to say. Is that clear for everyone? I mean, is this clear?
Yes, sir.
Okay. So how your new mean will be equal to old mean plus that constant. Suppose instead of adding a constant, I am multiplying by a 2 to this observation. Okay. So multiplying by 2, then it will be 2, 4, 6, 8 and 10, right? Then what will be the new mean? It will be 6 plus 12, 12 plus 22, 8, 30 divided by 5, 6, right?
Yeah.
Then what is the concept? Suppose your new y observations, this is okay, this is it. So your old mean is 3. So can I say 3 into 2? That means your new mean is equal to old mean into that constant. Is that clear? Suppose you have observations like 1, 2, 13, 15, 19, 18, 20, 22, then 30 and all things. Let's take, I'm assume the mean of this all observation is, let's take is 23, right? Just hypothetical, it might be wrong, I'm assuming. Then I'm saying after adding 5 to all observation, then what will the mean? Then you have to add the 5 to all observation, then compute the mean of that observation. It will become some tedious task, right? Then if you know the property, your old mean is 23, so your new mean will be 23 plus that constant. Your new mean will be 28. Is that clear?
Yes, sir.
Yes, sir.
Clear for everyone? Yeah.
Yes, sir.
Okay. Now come to the, suppose 1, 2, 3, 4, 5. So mean for this observation was 5, right? No, it was 3, right? Suppose there is some extreme values, right? 105, let's take, right? Then what will be the mean of this data?
It will be plus, so it will be 15 plus 105 divided by 6.
So your mean will be 20.
20.
Okay. So if you see, mean is affected by the extreme values, because after adding a extreme value, your mean got affected. It's become 3 to 20. Is this clear? Means your average values, your mean values is affected by the extreme values. Is that clear?
Yes, sir.
Yes.
Yes, sir.
Now come to the median. Let me create a. See, for the categorical data, how did you compute the median? First, you have to arrange your data in ascending or descending order. Normally, we are arranging the data in ascending order, right? If your categorical data, then median most observation will be your median. But if it's numerical data, then first you have to arrange in ascending order. Then after that, you have to compute the, suppose you have to find the total number of observers. If it's odd, right? Then what will be the median?
N plus 1 by 2.
N plus 1 by 2th observation, not this.
Correct. 2th
Right?
observation.
2th observation, right?
Yes.
Suppose N is even, then what will be the median?
The average of the N by 2th observation and the N by 2 plus 1th observation.
Observation plus N by 2 plus
2
1
plus 1th observation.
divided by
2 average.
Okay. Now, yeah.
It can
So
be
suppose,
any value between n by 2 and n by 2 plus 1 observation.
sorry.
Sir, I was asking that is it necessary that we have to divide those two observations by 2?
Yes. For numerical data, you have to divide.
Okay.
Because see, median mean gives you some central tendency. So you have to consider the center value. Okay. So suppose what will the median of this data? Suppose instead of see, is already in ascending. Suppose your observation is 3, 2, 4, 1 and 5. Then first we have to arrange in ascending order. That means 1, 2, 3, 4, and 5, right?
Yes, sir.
Okay. So what will be the median of this data?
3.
And yeah, it's a small data, then you can easily calculate. Let's go by the formula. Your n is odd. You have 1, 2, 3, 4, and 5 observations, right? So you have to compute. Yeah, 1 second.
5 plus 1 by 2, 3. Third position.
Yeah, yes, please. 1 minute. Let me connect my. Yeah, now, yes. So if n is odd, then you have to compute the mean as n plus 1 by 2th observation. That means your n is 5 plus 1 by 2th observation. That means 6 by 2th observation. That means third observation. Your third observation is 3. So median is 3, right? Now, suppose I have added 5 and then 105, right? Then I have added this extreme value. Then what will be the median?
Be
Median will
3.5, which is third 3 plus
median will be third 3 plus 4 by 2, that is 3.5, right?
correct, yeah.
So if you see, after adding extreme values, your median is least affected by the outliers.
Yes.
Okay, and your mean is it's affected by the outliers, but median is something it's least affected by the outliers. Okay, is that clear?
Yes.
So
Yeah, yes,
it
please.
won't be affected if like we have about that six now. Let's
Above?
six. We have about that 6 observations, like 1, 2, 3, 4, 5, then 6. So if we calculate that observations also, and then instead of 6 we put 105, then it won't be affected. Median won't be affected by, because here median is even least affected because the number of observations is increasing. If it
Median
won't
is
be,
least.
median is affected because the observation is increasing, number of observations are increasing. If we
Suppose
will
it's
keep,
suppose it's the
yes,
suppose instead of 5 it's 105.
yes,
Then
it
again
will
median will be 3.
3, yes. So it is not going to affect it if the number of observations are same and we take the
But
remove
it's same. Suppose Nisi for a data, okay,
yes,
for a data, suppose you have this. So initially you have median, you have data, right? This initially you have data, right? Then
yes,
you find, yeah, this is the extreme value, this is something outlier, but median for this is 3.5, and you want to remove this outlier. Normally in data science we removing the outliers, right? Then you got these things, okay? Then median is 3. See why I'm saying, why I'm taking this as an example. Reason behind it, median is least affected, not most affected by the outliers. Most affected by the outliers, it can be same, but it may be least affected by the outliers. Okay, if it's affected, then if it will be, it will be least affected.
oh,
Is that clear? Okay,
Prashant, I have a question. See,
yeah, yes, please.
suppose after 105, suppose you write 106, 107, 108, 109, 110, correct? So that makes it 11 observations.
Okay.
So 105 then becomes the 6th observation which is a median. So it also depends on the data set. Okay, whether
Yes, it will depend on the data set.
Whether
It's
or not.
okay. It's okay, Ranjani. But
Yeah.
what it's how many extreme values can be in your data set, right?
Okay, got it, got it.
anymore
Okay.
represent
You are
outlier.
see, initially you had 1, 2, 3, 4, 5,
Yeah.
and you, for your intention, you are adding
6, 7, correct.
6 extreme values. Okay.
Correct.
So if your data is something, so accordingly this previous data can be, it might be 91, 92, 93, 94, or 85 kind of.
Okay.
So what is the meaning of taking the example is median is affected by the outliers, I'm saying, but it least affected by
Got
the
it,
outliers.
Prashant.
Got it?
Thank you.
Is this
Yeah,
clear?
got it now. Got it.
Okay. Suppose 1 your observation was 1, 2, 3, 4, and 5. Okay, so median is 3. Suppose I have added a constant 4. So what will be this? This will be 5. This will be 6. This will be 7. This will be 8. This will be 9. Then what will be the median for this data set?
It will be
7.
7. Yeah.
So this is your old observation. Old observation I am representing as xi. This is a constant. This is your new observation after adding this constant. Then see how your mean. What I can write? I can write it as 3 plus 4. That means your new median I'm writing as n dot m is equal to old median plus that constant. Okay, so this is for the small data. You can easily compute, you can add the that constant to all the observation and then compute the median. Suppose there are 100 observation and median of that observation is, let's assume hypothetically it's 130, 130, right? Then I said to all the observation I have added to 5. Then what will be the new median? Then if you do not know the property, then you have to add the 5 to all the 100 observation, then compute the median of that 100 observation. But if you know the property, your old median is 130, then your new median will be 130 plus that constant. Is that clear?
Yes, sir.
Okay, now suppose I multiplied by a constant. Okay, sorry, yeah, suppose I multiplied by a constant. Instead of adding, I multiplied by a 4. Okay, so here I did some, let's take I multiplied by the 4. Then what will be the new observation? It will be 4,
28.
it will be 8, it will be 12, it will be 14 or not 16, it will be 20, right?
Yeah.
What will be the new median here?
12.
12.
Yeah.
So what will be, what is this? This is old median multiplied by
Constant.
that constant.
Huh.
That means your new median is equal to old median into that constant. So this is the property. That means if you want to add to all the observation, then your new median will be old median plus that constant. If you want to multiply it by a constant to all of the observation, then your new median will be old median into that constant. Is that clear?
Yes, sir.
Is that clear for everyone?
Yes,
Yes, sir.
Yeah, yeah.
Okay.
So this way,
Come to the
mean and
mod.
median are very similar.
Very similar. Mod is
Yes.
also similar.
Oh, okay.
Okay. Suppose your observation is 1, 1, 2, 3, 4, right? Then what is the mod? 1.
1. Yeah.
Okay. Suppose I want to add a constant 2. Okay. C means constant. I want to add a constant to all the observations. Then it will be 3, 3, 4, 5, and 6. Then what will be the mod?
3.
Mod is the 3. So
Yes.
I can write as 1 plus 2. That means your new mod, I am writing as MO, is equal to old mod plus that constant. Is that clear?
Yes, sir.
Okay. Suppose I have multiplied by a 3, then what will be? It will be 3, 3, 2 into 3, it will be 6, 3 into 3, it will be 9, 4 into 3, it will be 2, 12. Then what will the new mod is? 3.
Yes.
Okay.
Yes.
So it is 1 into 3. That means your new mod is equal to old mod into that constant. Is that clear for everyone?
Yes.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
And suppose come to the extreme value. Suppose 1, 1, 2, 3, 4 is there and 105 is there. Okay. Again, it will depend on according to data. But for this, your mod is 1. Okay. For this, your mod is 1. Right. So suppose your 105 is 2 times. Okay. So, I mean, it will depend on the data. But according to this example, your it's the same as the median. That means mod is also least affected by the outlier. Right, it depends. Suppose 1 is your 3 times, 4 times, 105 is 2 times or 3 times something. So in a, what is the intuition? Intuition is mod is least affected by the outliers. Is that clear for everyone?
Yes, sir.
Yes, sir.
Okay. Now I think we have covered the central tendencies, means mean, median, and mod. Okay, come can you tell me what are the measures of dispersion? What are
Range, variance, and standard deviation.
range?
Variance and standard deviation.
What about quartiles and percentile?
I don't think so. I don't know. I could be wrong.
Okay. What IQR can be measure of dispersion?
Yes, 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 yes.
Okay, so can you tell what is the range? What range tells us? It's just a simple by the word you can define the range.
The extreme limits within which all the output would fall.
Range is nothing but the maximum minus minimum of a data, right?
Yes.
And see, range is something which is sensitive to outliers. Okay, why? Suppose our data set is this. Okay, then what will be the range for this data set? 5 minus 1, that means 4. Is that clear? Now, suppose I have added extreme value, then what will be the range of this data set?
104.
104, right? So it's sensitive to outliers. See, sudden it's change a lot, right? So your range is sensitive to outliers. Is that clear? Because it's nothing but the maximum value minus minimum value. So it might be maximum value 1001 and minimum value as 100. The range will be sensitive to in respect of the outliers. Is that clear?
Yes. Yes.
Now come to the I think next topic is variance. Okay, can you tell me what variance tells us basically? What is the need of variance?
It tells us how much the data spread out from the mean.
Yes, correct, Ranjini. It tells us what is the spread, what is the deviation of values from its mean. That means suppose I'm talking about the population variance, there is two variance formula. Population variance is nothing but 1 upon n summation I equal to 1 to n xi minus x bar square. No, it's xi minus mu square basically. It's mean. So 1 by n summation xi minus, you can take as x bar also because mu is equal. So this is the your values. You have to take the, I mean, you are considering the deviation from its mean, or you are taking the square. See, can you tell me, is variance affected by the outliers?
So it is
Yes.
least affected by.
Least affected.
Why?
Because range and variance are both.
No. See, variance
If
is not
range
same
is
as the
least
range.
affected.
See, your mean is affected by the outliers, you know.
Yes.
Yes, sir, it will be affected.
Affected.
Okay. In the previous one, explained why mean is affected by the outliers. Okay, that means your variance is also affected by the outliers. Okay, what is the formula for sample variance?
1 upon n minus 1 summation xi minus x bar का whole square.
Xi minus x bar. This is the difference between the population variance. Suppose your xi is the observations. Okay, I want to add a constant to all the observations of xi. Then what will be the new variance?
It will be the same.
It will be the same. And if I want to multiply by the constant c, then what will be the new variance?
So c square of old variance.
Should I derive, or you know how it's come? Suppose I'm taking the example of sample variance. Okay, xi minus x bar whole square, right? So suppose this is our old observation. I want to add a c, then what will be yi? It will be xi plus c, right? Then what will be y bar? That means x bar plus c, right? Here I wanted to know what will be the new variance. So suppose s square new I'm taking as n 1 upon n minus 1 summation I to n yi minus y bar square. Okay, see, this is our initial formula. Now I wanted to know how it is. So after adding the constant, what it will be? Y, instead of yi, I can write as xi plus c, right? So my new mean will be x bar plus c. So I can write as x bar plus c whole square. Is that clear?
Because the
Is this clear for
subtraction
everyone?
takes place, the addition gets nullified.
Subtraction.
Because of the subtraction, there's even though it is getting added on either side, it gets cancelled.
Here your c got cancelled, right?
Yeah, so it doesn't make a difference. It will remain the same.
Yeah. So we get new variance as the same as the old variance. Is that clear for everyone? Suppose you add a constant, then what will be this? It will be 1 upon n minus 1 summation c times yi minus c times y bar whole square. So your c square will be outside. It will be 1 upon n minus 1 summation yi minus y bar square. So this, sorry, xi, it will be x bar because I'm placing as a instead of y, xi is x bar. So my new variance, when I have multiplied by the constant, it is c square into the old variance. Is that clear for everyone? Is this clear? I mean, addition of a constant to all the observation in case of variance and standard deviation does not make any difference, but multiplication will be square in case of variance. Suppose I'm talking about standard deviation. So your new standard deviation will be same as the old standard deviation because standard deviation is nothing but the square root of the variance, right? So for this, your new standard deviation will be what? C times old standard deviation.
Yes.
Because if you take the square root, then c square will be c, right? Can you tell me what is the need of standard deviation? Because if this is the nothing but just a square of the square root of the variance. What is the need of then? Formula is same. What is the need?
So it tells us how dispersed are values from their mean.
Okay, in variance is also tells us you.
But here what
The
happens is
dispersion.
when it is base, the units are different.
Yes, yes, Ranjini, you are correct. See, suppose your xi is something age of a person, right? Then age will be in year, right? When you compute the variance, your values will be in year square because formula is summation something this square, right? But to I want to in a original unit in which our data is, then standard deviation is nothing but the square root of the variance. So square root of the year square will be the year. So it is easy to compare it with the original. Is that clear for everyone?
Yes.
Okay. And one more formula you can remember or you can, right? So what is the population variance? Sigma square is 1 upon n summation of xi minus x bar square, right? And sample variance formula is 1 upon n minus 1 summation I to n xi minus x bar square. Is that clear? Now, can I write n times of sigma square as summation I to n xi minus x bar square? These things.
Yes, yes.
Okay. Also, I can write as n minus 1 times of s square as summation of I to n xi minus x bar square.
Yes, yes, yes.
So these things is same as these things. So here I can write n sigma square as n minus 1 sigma s square.
Yes.
Because this is equal to this, so I can put the these things in place of these things, right?
Yes.
See, if a equal to x and b equal to x, then I can say a equal to b.
Yes.
Okay, so here n sigma square equal to n minus 1. So you can memorize this formula or you can do this formula, because suppose question is like population variance is given to you or population standard deviation is given to you, sample variance or sample standard deviation is given to you, and you are asking about what is the number of observation, then you can compute from this formula or not.
Chance, I have a question. See, the n which is used
Yes.
for a sample will be smaller than the n which is used for a population. So how?
No. Suppose your n is 10, right?
Ha.
Then in population variance, you will use 1 by 10, and sample variance, you will use 1 by 9.
Okay, okay, okay. See, like for example,
Okay.
if we are saying out of 100 people, a sample of 10 is taken, then n in sample is 10 and n in population is 100. That's what I'm asking. Whether
No,
we can.
that is another case, Ranjini. This is something,
Acha.
suppose for a given data of 10 observations, right? Suppose marks of 10 students is given to you.
Yeah.
You are asking about calculate the population variance of these 10.
Correct.
That means you are considering as a population.
Okay, okay, okay.
And sample variance of these 10, then you have to consider as 1 by 9.
Okay,
And
okay,
summation.
okay. Got it, got it.
That is the basic difference.
Got it, got it, got it.
So suppose population variance of a particular data is given to you, sample variance of particular data is given to you, and you are asking about number of observations, then you can calculate. Okay. So here you can take a screenshot, or you can whatever, you can write it down. Is that clear? What I'm trying to explain here?
Yes. Yes, sir.
Yeah. There is one more formula. Suppose s square is there, 1 upon n minus 1 summation of xi minus x bar square, right? So I can write as n minus 1. So just expand this. So I can write xi square plus x bar square minus 2 times of xi into x bar. I can write.
Yes, yes.
Okay. Now let's take summation inside the bracket. So I can write summation of xi square plus summation of x bar square minus 2x bar summation of xi, because summation is for I, right? Now 1 upon n minus 1 summation of xi square plus I can write this n x minus 2x bar into n times of x bar, because if you see x bar is what? Summation of xi by n. So I can write summation of xi as n times of x bar or not. So instead of summation of xi, I can write as n into x bar. Is this clear?
Yes, yeah, sure.
And summation of x bar square means what? Summation of n x bar square means you are adding x bar square up to n times, right? X bar is a constant, so it will become n x bar square, this term. Is that clear?
Yes, because you're taking the summation.
Yes,
You'll
yes.
get
And
cumulative.
summation is for the constant. Now, I can write 1 upon n minus 1 summation of xi square plus nx bar square minus 2 nx bar square, because there is here is 2 and x bar. So I can write 1 upon n minus 1 summation of xi square minus nx bar square.
Yes.
I can write.
Yes, 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 yes.
So this is the expansion of this formula. Similarly, you can do for the population variance. You will get this is same. Okay. Why I have write this formula? Because suppose you are asking about, I mean, you are given to the population sample variance of 10 observations, and mean is given for that observation. Suppose you are asking about what is the summation of xi, values of summation of xi square, then you can compute. Are you getting my point?
Yes.
Okay, you can compute by this expansion formula, right?
Yes.
Is that clear for everyone?
Yes.
Yes, sir.
Now you can write it down or take a screenshot, whatever you want to do. Okay, should I create a new page?
Sir,
Yeah, yes, please.
can you share this notebook?
Okay, actually, you will be able to understand after because there is some messy type of things. Yeah, there is basically two main things. We'll try to share. Okay, we'll ask to the support team. There's two main things. These two for this one formula. I writing down the formula, and this is square gen minus 1 s square, which is not in lecture video, and this formula. Okay, so you can write it down or take a screenshot. For I mean, meanwhile you can take, and we'll try to share this. Okay, you took it.
Yes.
Okay, now come to the next topic, which is about percentile. Anybody wants to tell what is the meaning of percentile? What is percentile tells us?
Number of people who are less than you. If it's 99 percentile, you have 99 percentile. That means 99% of the population is below you.
Suppose I'm saying 30th percentile, right? Suppose there is 30th percentile. So meaning of percentile is 30% of the data will lie below this value, and remaining 70% of the data will lie above this. Is that clear? So suppose I'm saying 25th percentile, that means 25% of the data will lie below this value, and remaining 75% of the data will lie above this value. That gives percentile. Is that clear? Now, how to compute the percentile? Anybody? First, you have to, you have to count the number of observation. Then what is the value of p? Suppose you are asking about 30th percentile, then value of p will be 0.30. Suppose you are asking about 90th percentile, so your p value of p will be 0.90. So first step is you have to arrange your data, right? Second thing, you have to calculate the value of np, right? If value of np is not integer, then what will be the next step?
We take the floor of the value.
You have to consider the
floor
next
integer.
You can say next smallest integer, right? Now, if np is in integer,
then we already know what the
you have to take the values of positions npth observation and np plus np plus 1th observation. You have to take the average of these two values, right? Is that clear? This is the concept to calculate the percentile. Okay.
Prashant, why we need to take np plus 1th observation by npth observation is not enough?
See, it's an integer, right?
See,
for decimal.
Because see, for decimal, we take the next smallest integer. That is if it's not an integer. If it is an integer, why we need the n plus 1th observation?
Okay.
Like, do we need it, or it's enough that we have the npth observation?
I don't think, because according to computing criteria percentile, we have to take the average of npth observation and np plus 1th observation. What is the funda behind this? I will search about it. Okay, I will search and let you know.
Okay,
but what I'm thinking, because if you observation like 12, 15, let's take 13, 14 and 18, then suppose your np is integer, then what will be concept? Because in practice, in best practice, we are interested in kind of like what say measure of central tendency, like central values.
Correct.
So I think this might be a reason for taking the average of integer and next integer, because okay, I will think about it. Okay.
Okay.
Meanwhile,
See, assume that you have 5 data points here and you're considering the 20th percentile. So NP is 5 into 20 upon 100. Correct?
One. That means 1 will be there.
Yeah. So that means the first observation is, so your answer is 12, right? So do you really need the next observation?
Okay. I got your point. Why this is okay. But okay, I will search. I will think
Thank
about
you
it.
so much, Prashant.
But meanwhile, we'll just remind me in the next session. Okay.
Sure.
Meanwhile, this is the computing criteria for this one. Okay. Annotate the shared column. Okay. So this is the computing criteria. So what is n is here? Your 5. Suppose I'm interested in 30th percentile. Okay. So p will be 0.30. But what is the first step? What is, maximum people make mistake. They did not do in ascending. They normally do not doing in ascending order, right? Data in ascending order. So what is the first step? You have to arrange in ascending order. That means 12, 13, 14, 15 and 18? No. 12, 13, 14, 15. Yeah, these are the my first steps. I have to arrange in assembly. So suppose I am interested in computing the 30th percentile, then what will be the value of NP? 5 into 0.30, that means 1.5.
5, huh?
So this is in decimal, right?
Correct.
So I have to take the next smallest unit, that means second
Observation.
observation. So second observation is
13.
13, right?
Ah.
So suppose your P is 0.40. I'm interested in 40th percentile. So what will be this? 5 into 0.50, it will be 2.
2, huh?
Right?
Yeah.
That means if it's in integer, then I have to take the average of second observation plus third observation.
Okay.
Right? So that means 12, no, 13 plus 14 divided by 2. It will be 27 divided by 2, which will be 13.5.
5.
So this is the criteria for computing the percentile. Is this clear for everyone? How you can how you have to compute the percentile?
Okay. Yeah, now I get it, because 40% means 2 data points are less than that and 60% is above that. So there are 3
Above
points.
that.
Got it. Thank
Yes,
you so much.
and yeah. Now I also got it, because that's why we are considering the measure of central tendency. We are taking the average. Okay, we are central tendency means central value. We are interested in central value.
Correct. Otherwise, what happens is if we don't take the average, but for 30 and 40 percentile, the value will be the same, which is incorrect.
Same. Yes.
Okay. Got it. Thank you so much, Prashant.
Got it? Yeah. Thank you. Now, can you tell me median is what? 50th percentile?
Yes.
So, you know what is the quartile? Quartile means in general quarters. That means 1/4 of the data set, right?
Correct.
Suppose this is your whole data set. So there are 3 quartiles: first, second, and third. So quartile is divided your data into 4 equal parts. That means 25% is this portion, this portion is 25%, this portion 25%, this portion is 25%. And Q2 we are interpreted as the median, because median is what? It tells you the middlemost observation. That means 50% of the observation. So your Q1 is what? 25th percentile, okay, of the data set. Q2 is 50th percentile of the data set. That is same as the median. And Q3 is 75th percentile of the data set. Is that clear for everyone? What is the meaning of Q1, Q2, and Q3?
Yes.
Okay. Suppose for this example, 12, 15, 13. Okay. Let me create a new example. 12, 15, 13, 14, 18. So I'm giving to guys 2 minutes. And you know, formula of IQR is nothing but the difference between Q3 minus Q1, right? So I'm giving to you 2 to 3 minutes. Just tell me what is the value of Q1, what is the value of Q2, and what is the value of Q3, and after that we will compute the I. Okay, just 2 minutes will be.
So 12, 14, 15.
Prashant, you want the value of Q1, Q2, and IQR? Is that the question? Prashant?
Prashant, you're on mute, Prashant.
Yeah, hello.
Yeah, Prashant, you want Q1, Q2, Q3, and IQR, all the four, or what is it that you need?
Yeah, all four will be better.
Okay, fine. Yeah, got it.
You have computed or computing?
Yeah, computed.
Okay.
So if everybody is, I can wait till everybody finishes.
Yeah. If anybody wants to tell, then we can solve together. So just tell me what will be the first step.
So ascending order, arrange in ascending
Okay,
order.
that means 12, 13,
14,
14,
15, and
15,
18.
15, 18. Because Q1 is nothing but the 25th percentile of the data, right? That
Correct.
means we have to go through the computational criteria of the percentile, right? So
Correct.
here our n is 5. What will be our p?
0.25.
0.25 because Q1 is the 25th percentile. So
Percentile.
what will be the NP? 5 into
1.25.
that means 1.25. That means this is 1.25. So next smallest integer will be second observation, that is 13, right?
Yeah.
So Q1 it will be 13. Now Q2 is what?
50%.
50, that is n is equal to 5, p is equal to 0.50. So NP will be 5 into 0.50, that means 2.5. That means third observation because it's in decimal. So next value will be 14. So Q2 is 14. Also you can do like Q2 is the median, then middle most observation is median. Okay.
Yes.
This is just for next for Q3. So n is 5. What will be p? 0.75 because
0.75.
Q3 is 75th percentile. So NP will be 5 into 0.75. It will be 3.75. That means fourth observation. That means 15. So what will be the IQR?
It'll be 15 minus 13. That is
30.
Q3. Q3 minus
Yeah, that is
2.
So your IQR is interquartile range is 2. Okay. And you can also do by the box plot. Suppose this is the box plot. Your box plot is showing this is minimum value and this is shows maximum value. This shows Q3. This thing shows Q1. And according to the data, Q2 can be very mean. It can be here. It can be here. But Q2 will be the middle of the all the observation. So this box plot shows you 5 number summary. 5 number summary, minimum, Q1, Q2, Q3, maximum. This 5 values is known as the 5 number summary for a data set. Is that clear for everyone? Suppose box plot is given to you and its value is, this is something 15, this is 10, this is 5, this is 3, this is 20. Suppose I ask with the help of box plot, tell me value of IQR. Then you can easily tell me what will be the IQR for this. What will the IQR?
10 it is.
10 because 15
Yes,
minus
10.
5 will
Sorry.
be 10, right?
Yes,
Q3
10.
minus Q1. Okay. Now come to the last topic of the week 3, which is called the outliers. How can you compute the outliers? Outliers you can compute is nothing but there is formula. If your any value is less than Q1 minus 1.5 times of IQR, then that value considered as outlier. Or if any value is greater than Q3 plus 1.5 times of IQR, then that value is considered as a outlier. That means suppose you are given a data set, then you have to compute this quantity. If any value is less than this quantity, this whole quantity, that will be considered as the outlier. And you have to compute this value. If any value which is greater than this quantity, then that will be considered as an outlier. Is that clear? I'm not computing whole thing
Repeat,
because
please.
it might take time. So is that clear how you can interpret the compute the outlier?
Yes.
Okay. Now, so I think week 3 concepts is covered, right?
Can
Come
you
to the
repeat
week
the
4.
concept of outlier, please?
Okay, suppose I'm asking about, tell me the what are the outliers for a data set, right? So for a data set, suppose outlier is asking about, then any observation which is lies between, which is less than 1.5 times of I, which is less than, suppose you are given the data set something, okay, and you have computed Q1, you have computed IQR with the help of this data set, and if any observation is less than between this, less than this whole quantity, that will be considered as a outlier. And if any observation is greater than 1 Q3 plus 1.5 times of IQR, that value considered as a outlier. Is that clear? That means
Yes.
if you have to compute this quantity, you can compute it, and if any value is less than this suppose Q1 minus 1.5 times IQR is coming out to be 15, right? And there is a value in your observation which is 5. Then this 5 you can consider as a outlier. Suppose this quantity is coming out to be 210, hypothetically, and there is a observation in your data set which is 920. Then this value is greater than this whole quantity, then this will be the outlier. That's it.
Yes.
Okay. Now we cover. See, till week 3 we know we were yesterday like discrete data, continuous data, mean, median, mode, outliers, percentile, quartiles, and all things. Now in week 4 we will interested in knowing the association between two categorical variables. Okay. Okay. Now tell me first of all, tell me what is the meaning of association? Anybody?
Relation between two variables.
Relation means what? That is the meaning of association. I'm asking about association. Anybody? These things I can say. Hello, am I audible, right?
Yes, sir.
Yes,
Yeah.
yes.
Yeah, what I'm saying, association means what? Suppose you know you have information about one variable, right? If information about one variable provides the information about the other variable, that means those two variables are associated, right? Now, is that clear? What is the meaning of association? How can you say these are associated? That means you are knowing information about one that provides the information about the another variable, right?
Can you give us an
Yes, sir.
example? A
Yeah,
small
I'm
example.
giving. Yeah, I
Okay.
will give example.
Okay.
Okay. So you have remembered that lecture video example. Two categorical variables. One categorical variable was gender, and one was ownership of a phone, right?
Yes.
Right.
Yeah.
So these two, first of tell me, owning a phone is a categorical variable or numerical variable?
Categorical.
Categorical, because it can be gender or categorical, that means female or male, right? So this is female, this is male, and this is yes, and this is no. Let me write once again. Yeah. So female here, and okay. So suppose there was 10 female and around, take this is as a 35, and this is, you can say, So I can say let's take this as 15 and this is let's take as a what it I can take 41, right? Now what is suppose I'm saying how many total female is taking, I mean what are the total number of female who are owning a, I mean total number of female for ownership of phone?
10.
10.
And what is the total number of females?
45.
45.
Total number of male?
55. 55.
No, it's 56, right? Let's take is 40, then it might be 55, right? Right? Now, how many for S? 25. How many for this? 75, right? So, grand total is 100. Either you can compute it by this one or this. Now, say association between two categorical variables, we can compute by either row relative frequencies or column relative frequency. Okay. So what is the relative frequency? Frequency divided by total number of observations, right? So for female, this is yes, this is no. How can you compute the row relative frequency? 10 by 25 or 45?
45 because it's row.
Row, because this frequency divided by row relative frequency, I mean row total. So 35 divided by 45. Similarly, for the male, it will be 15 divided by 55 and it will be 40 divided by 55, right? So grand total row will be 25 divided by 100 and 75 divided by 100. If you see what it will be, 10 divided by 25, 45. It's something 0.22, that is I can write 22.22%, right? I mean after multiplied by 100, right? What will be this quantity? Hello, what will this quantity? This is will be something this, right?
Yes.
And what will be this? 27.27%, right? What will be this?
73%.
73, around 73%. Okay. Now this is 25%. This is 75%. See, what is the fundamental behind this? If row relative frequencies are approximately same, right? Then there will be no association. Okay. If row relative frequencies are significantly different, then there will be association between two variables, between those two categorical. Okay. Is that clear?
Yes.
Okay. Now, and you can compute by the, by the, what I'm saying, column relative frequency as well. Okay. And now come to the, what is the stacked bar chart? Okay. Suppose I'm drawing a stacked bar chart. Okay. This is nothing but the segmented bar chart. Okay. This is for, suppose this is female and this is for bar for male. Suppose 0, 20, 40, 60, 80, and let's take this 600. Okay. So how many females for not owning a phone? 10. Sorry, owning a phone 10 and 35 not owning. Okay. So I'm taking as 10 is here. Okay. And rest 35 is not owning a phone, right? So I'm writing, I mean, this is, suppose this is the green region, right? Okay. So similarly, how many males not owning a phone? 40, right? And 15 owning a phone. So suppose 15 is, I'm taking as this here, okay? And not owning a phone. This green region is for not owning a phone. And this black region is for owning a phone. Okay. So I can draw by the this, I can easily know by this stacked bar chart what is the count for not owning a phone, for owning a phone, not owning a phone, or owning a phone, right? If you want to compare by the 100, I mean 100% stacked bar chart, then what will be this? This will be 100, right? this will be female, this will be for male. Okay, suppose this is 0, this is 25%, this is 50%. So what percent for female owning a phone? 22.22. Okay, so 22.22 will be around like this. Okay, okay, and for male owning phone 27.27. Okay, so 27.27 is this. Okay, so rest of the this things will be okay. So if you see, you can easily see change in this variable, change in this y axis what showing is about ownership, right? And this variable is showing, this axis is showing gender, this is showing about ownership. So change in one variable, if it shows change in another variable, then it's associated, right? So if you see, these are approximately same. We can say approximately same, not exact, too much difference, but approximately same, right? Not a significant change. If you go for the change in this variable, not a significant change in this variable. Are you getting my point?
Yes, because one is 22, other is 27 for owning. And the other one is
Okay.
like area is approximately the same on the stack bar chart.
See, and you see what come. See, suppose let's take another example. Okay, suppose your first row is coming out to be, let's take 24%, this is 72%, and for male is coming out to be 25%, this is 74%, and for grand total is coming out to be 26%, or just a hypothetical example. Let's take it 76. If you compare each row, then there is, I mean, these all are approximately same, right? If row relative frequencies are approximately same, there, then that means there is no association between the two categorical variables. Okay, if there are significant difference, suppose this is 24, this is 30, you can say 32. Okay, so the whole row, and this is 70, and this is, let's take 21, and this is let's take, okay, let's take 80 or 79, whatever. So here significant difference is there, right? 24, 32, 70, 76. So row relative frequency, there are significant difference, then there is association between the categorical values. Is this clear for everyone?
Yes.
Okay, now come to the scatter plot. Okay, anybody wants to tell what scatter plot tells us? Anybody?
Distribution
Feel
of the
free to
data.
say.
Dispersion of the data.
Okay, anybody else?
Outliers.
Outliers, you can see
Association
it
between
tells
two
us,
numerical variables.
yes, Naresh, you are right. It tells a quick, it gives you a quick idea for the association between the two variables. So this, there is one numerical variable x, one numerical variable y, and you draw a scatter plot kind of things, and you find the pattern of these things. Okay, then you can say there is a positive linear something association between two variables, right? Is this clear?
Yes.
Okay, so what is the meaning of positive? That means if your one variable is increasing, that means your y increasing. As your x is increases, your y is increases. That means they are moving in a same direction. Suppose after drawing, plotting a data, you are getting this such type of pattern. Then what is this? Negative slope. Right?
Yes.
One second. Yeah, that means your x is increasing, but y is, your, as your x variable is increasing, your another variable is decreasing, right? So from the scatter plot, you can get a quick idea about the association, linear association between the, suppose one observation is there and one other observation there, then what this two observation is showing? Hello.
Not associated.
No, not again, not.
Outlier.
Suppose you got a
Outlier.
pattern. Yes, Rajni. Yes, you are right. These two observations are outliers because in a scatter plot, what are outliers? The observation or a point that are farthest from the your pattern, right? So if any observation lies between like farthest distance from the pattern, then you can consider it as a outlier. Okay, suppose in scatter plot you find this type of something, kind of something. So what is this? That means no association, right? No pattern is there. Is that clear? Is this clear till now? Till now everyone got the concept? Then we can move ahead. Okay. Now come to the next topic as covariance. What covariance tells us? It gives us, it quantifies, it gives us basically the strength of linear association. And there is formula for covariance is nothing but covariance between two variables x and y is nothing but the 1 upon n summation of xi minus x bar to yi minus y bar. This is formula for the population covariance. What will be the formula for sample covariance? 1 upon n minus 1 and rest of the thing will be same. So this is the something covariance formula. So see, by the covariance formula, it also quantifies the linear association. But suppose for a data set, you calculated the covariance for that data set, you found to like 200, and for another data set, you find covariance as minus 20. Then it will not giving it will not I mean, it is not giving you a how you can find the strength, how can you say which one is greater, which one is less. I mean, there should be a fixed criteria, right, for which you can say, yeah, these two variables are positively correlated or positively associated kind of things. So for covariance, by the behalf of covariance, we are not able to do this, such type of things. And one more issue is there. Covariance gives the values in unit. Suppose your x is variable is your age of some persons and y is variable of weight of a persons. Okay, then covariance will give you values into, let's take 200. So it will be 200 year into kilogram, right? So covariance has units. Are you getting my point? What I'm trying to say here? Because x is your year and y is your kilogram, then your final covariance will be in year into kilogram.
Yes.
Okay.
Yes, sir.
Okay. So covariance has units. So by the formula of covariance, by the values of covariance, we are not that much able to conclude about the strength of the association between the x and y. For that, correlation comes into the picture. Correlation R between x and y is nothing but the covariance of x comma y divided by standard deviation of x into standard deviation of y. Suppose your y covariance is into year into kilogram, then standard deviation of x will be in also year and standard deviation of will also be in kilogram. So all the units get cancelled out. So R is something which doesn't not, which is unitless measure, right?
Yes.
And it has minimum value -1 and maximum value as +1. So from here we are able to know what are the strength between the two variables. That means if your R is close to +1, then you can say x and y are positively correlated. If your R is close to -1, then you can say x and y are negatively correlated. If R is close to 0, then you can say there is no association between the x and y. So that's why we need the correlation, which is unitless measure, while covariance is a unit measure of with units. So is that clear till now? Is this clear for everyone?
Yes.
Okay, now okay, come to the yeah, suppose R is there, okay, you know covariance of x comma y, okay, this is something sx into sy, okay, and one formula is there, a summation of xi minus x bar into yi minus y bar divided by square root of summation xi minus x bar square into summation yi minus y bar square. So this is the formula. See, you can use here sample or population as well, but you I mean one more thing you have to clear, if you are using the population covariance formula, then you have to use the population standard deviation numerator and denominator. If you are using the sample covariance formula, then you have to use the sample standard deviation formula, because if you use the population covariance formula, then it will be 1 by n summation xi minus x bar yi minus y bar, right? So sample standard deviation will be what? Population standard deviation will be what? 1 upon n summation xi minus x bar square, right? Square root of 1 by n summation yi minus y bar square, okay? So here 1 by n got cancelled out. So you will get this formula, right? Because square root of 2 into square root of 2 is same as 2. So square root of 1
Yes,
by
sir.
n, square root of 1 by n is 1 by n. So this 1 by n is will get cancelled out by this one. So this will become as n. Suppose you are using the sample formula, that means n minus 1, n minus 1, n minus 1. So again, you will get this formula. So what is the meaning for this formula? What I applied this one. That means if you are using the population covariance, then you have to use the population standard deviation. It's not meaning, suppose you have to, I said calculate the correlation coefficient, then you have calculated the covariance by the formula of population, then you are calculating the standard sample standard deviation. No, if you are using the population, then in the denominator you have to use the population. If in numerator you are using the sample covariance formula, then you have to the sample standard deviation formula. Is that clear for everyone?
Yes. Yeah.
Okay. Yeah. Yeah, sir. There are some criteria. I mean, some ranges where you may know when will be strong and positive correlation something. So I am writing some. I mean, for what range of R it will be strong and positive. For what range of R it will be weak and positive or weak and negative. So please note it down, or you can take a screenshot. Okay. If your R is lies between 0.75 to 1, then you will say, suppose you computed the correlation coefficient and your R lies between these two values, then you will say there is strong and positive linear relationship. Okay. Today you people got tired also, because I think from 4 o'clock you have continuously session, right?
Especially.
So for this region 0.05 to 0 less before 75, you can say moderate and positive linear relationship. Okay. Suppose your R is lies between 0.25 to before 0.5, then you will say weak and positive linear relationship. Okay. Suppose your R is lies between minus 0.25 to 2.25, then you will say absence of linear association. Okay. Okay. Suppose your R is lies between minus 0.5 up to 0.25, then you will say weak and negative linear relationship, and minus 0.75, then you will say moderate and negative linear relationship. Okay, and if your R lies minus 1 to 0.75, then you will say strong and negative linear relationship. So you can take a screenshot. I mean, there might be question like you computed the R and you are asking what is the what will be what is the strength of the linear relationship. So by this value you can say yeah, strong and positive linear relationship, moderate and positive, weak and negative kind of things. Okay, so you can take a screenshot for this. Hello.
Yes,
Yeah,
sir.
yeah, please let me so you screen right, then we can move further. Okay,
Yes, sir.
okay, now yeah, one more thing. What suppose it might be uh, for large values of x, small values of y, what will be the positive or negative kind of things. Okay, so I'm trying okay, suppose your x-axis, this is your bar, right? Suppose x bar is somewhere is this and y bar is somewhere is this. Okay, now so can I do this? Suppose scatter plot, I mean scatterness of set is kind of this one. Okay, now you people will tell me, suppose what will be the xi minus x bar here? Less than 0 or greater than what? Hello?
It will be positive.
Xi minus x bar will be positive
No, the
for this.
product. Okay, both will be negative and the product will be positive. Sorry.
Yes, it less than 0. Similarly, y minus y bar will be less than 0 for this, right?
Yes.
Come to this region. What will be xi minus x greater than 0? Because see, x-axis is this, x bar is this one, okay? So it's kind of above. What will be yi minus y bar?
Negative.
Negative.
Yeah.
For this region?
Yes.
Xi minus x bar greater than 0.
Yeah.
About yi minus y bar?
Also positive.
Also positive. So xi minus x bar will be less than 0 and yi minus y bar will be
Greater than 0.
greater than 0. So tell me, what will be the product of these two? Product of xi minus x bar into y minus y bar will be greater than 0 or less than 0?
Greater than 0.
Greater than 0, because product of two negative values is coming out to be positive, right? So what will be product of x bar into y minus y bar? Greater than 0?
For the first and the third quadrant, it will
Right?
be positive. Second and fourth quadrant, it will be negative.
Will be negative because minus 2 into be minus 6, right? Product of these two will be positive. Right? For this region is negative. product of xi minus x into y minus y bar. Now, suppose I'm asked, it's what will be your correlation, positive or negative for this region? Suppose xi minus x bar is less than 0, y minus y bar less than 0. So your R will be coming will in negative.
Positive.
Positive. Why? Because in Cohen's formula you multiply product of these two value, right? Right.
Yes.
So for this region, if your xi minus x bar is less than 0, y minus y bar less than 0, then covariance will be in positive. If covariance is in positive, that means you, by your formula of R, okay, your R will be positive, because in the denominator part is also is already greater than 0, because Sx is what? Square root of summation of square value y was summation of yi minus y bar square. So these two are already greater than 0. So it's depend on this. So is that clear? I mean, for what values of x and xi minus x bar, y minus y bar, how can interpret about the correlation? Is this clear?
Yeah.
Okay. Now the last topic of week 4 we will cover. After that, if you want, then we can move for the week 5 syllabus. Otherwise, we will cover in the. Yes.
Prashant, see, there's something where so R value goes from -1 to 1, right? Correct. And there's something which goes from 0 to 1. What is that?
0 to 1.
Something. The square of the R. What is that equal to?
Okay, okay. That is not.
Goodness
Okay,
of a
see
fit
this.
medium. Is it that?
Sorry.
Goodness of a fit medium, like.
Yeah, goodness of it.
Perfect,
Actually,
perfect.
this is just an interpretation of meaning of the interpretation is there, not a whole discussion, whole derivation of this is not in this your fundamental course. This is just nothing but your R is capital R square. It tells you the goodness of fit, right?
Okay.
Goodness of fit means it tells you proportion of the variance in the data set, which is explained by your explanatory variable means which is explained by x-axis variable. So goodness of it, you how good fit your straight line is. Okay. So by R square you can know about the goodness of it of your data.
Okay. So
just a meaning. Okay.
Okay, so small r goes from -1 to 1, and because we are squaring it, goodness of it goes from 0 to 1, correct?
Yeah, R square is 0 to 1. Okay. Now, till now, we studied association between two categorical variables, right? For which I can apply row relative frequency, okay, or I can calculate by the column relative frequency as well. Okay. If row relative frequencies for all rows is approximately same, then there will be association or not association.
No association.
No association. If row relative frequency are significantly different, then there will be association. Similarly, you can interpret for the column. And we have studied association between two numerical variables, right? For which we applied correlation coefficient, right?
Yes.
We have studied till now this one, right? So this is yi minus y bar square root of summation xi minus x bar square root of summation yi minus y bar. So this is the correlation coefficient. Now we studied association between two categorical variables. We studied association between two numerical variables. Then what about association between? Let me create a new page. That will be okay. Yeah. What about association between one numerical variable and one categorical variable? Okay. So for two categorical variables, we have method of row relative frequencies or column relative frequencies. For two numerical variables, we have correlation coefficient. For association between one numerical variables and one categorical variable, Which method we have to apply? Anybody?
Point by serial.
Yes, there is a method which is called point by serial correlation coefficient, right? I have read in a short form here. Okay. Now, so I mean, here we are interested in knowing the association between one categorical variables and one numerical. Suppose I'm taking a random data of gender. Okay, that means boys or girls, or marks. Okay, of okay. So I'm interested in knowing the whether gender and marks are associated or not. So gender is suppose it can be female, female, male, female, male, and male. Right? Now I'm taking marks as let's say 98, 68, 72, 65, 98, and 75. Okay. Now, so what point by serial correlation coefficient is? So see, you can compute absolute point by serial. Absolute, see, if in the question it is mentioned absolute point by serial, then it's okay. Otherwise, you see your gender variable will be some binary. Binary means it will take two things like female, male, kind of. I mean, you have to label by 0. Okay. So formula is correlation coefficient is y bar naught minus y bar 1 divided by standard deviation of x or population standard deviation. What will be? Sample standard deviation or population? Huh?
Standard deviation of x.
Which standard? Population or sample?
Um, Sample.
Anybody else? See, in the video, lecture video, there is mistake. Actually, it should be a population standard deviation. Okay. If you are saying absolute point by serial, then you can calculate, just take a mod of this value. Okay. So it's absolute point by serial. Can you tell me what is P naught? N naught by N? What is P1? N1 by N? Till now it's clear? I mean, interpretation of the formula. Hello?
Yes.
Yeah. Okay.
Can you tell us what is N0 and N1?
Yeah, no, I will explain like this. See, the categorical data will be such that in which we have to label. Okay. So I can label as a female as a 0. Okay. Male as a 1. Okay. Now, see, for the simplicity for calculating the point by serial correlation. Now, what is the P naught? It's the proportion for 0 things, right? So what is the proportion of 0 things? I mean, what is the number of N naught? I mean, not the number for not 3. And what is the number of number is 6. Total is 1, 4, 5. So it will be 3 by 6. That means 1 by 2. That means 0.5. Is this clear? For N1, it will be 1, 2, and 3. That means again N1 is 3 means number for 1 means which you have to label as 1. So N is 6. Again it will be 1 by 2 which is 0.5. This thing is clear, Anjana?
Yes.
Got it, yeah.
Got it? Suppose instead of 6 there is one male extra, right? Then what will be this? This will be 3 by 7 and P1 will be 4 by 7. Is this clear?
Yes.
Now, I'm continuing with this data. Okay, what your formula says? You have to compute the P naught, P1. I have computed P naught, I have computed with 7, 4 by 6. It total number is 1, 3, 4, 6, and number 0. That means 1, 2, 3. One is number of another category. One category So it's 3 by 6. Now we need to find the y bar naught and y bar 1. So what will be the y bar naught? Means mean of naught 1. Okay. So what will be the y bar naught? Anybody? No worry about that. Okay.
It will be 98 plus 68 plus 65 divided by 7 or whatever, 6.
68 divided 65 divided by
7? Oh, sorry, 6.
anybody else? And 8. This 68 plus this 65 divided by 7 divided by 6. Okay, anybody else? Yeah, if you speak, then your concept will be clear. I mean, what is the how you have to calculate the thing. So please, speak. Otherwise, I can tell you that directly, and it will take 3 to 4 minutes, and it will be finished.
Sir, your
Anybody?
voice is breaking.
Anybody else? Okay. Now is it okay?
Yes, sir.
Okay. So anybody else? How you can compute what will the y bar not?
So 90 plus 68 plus 65 divided by 3.
Average is sum of observation divided by number of observation, right? It's not about, suppose this is your x variable, it's not about x bar, it's about y bar not. That means average of only these three. Got it? So you have to compute the average of these three. So what will be the average of this three? These three, I think it will be 98 plus 68 plus 65. Yeah, yes, please. Sorry? Mean is coming to, out to be 77, right? 3, I think your voice is breaking for me. So is that clear? What will you want? Mean of
2 plus
this value.
98 plus 70.
Okay. Mean of this value, mean of this value. That means 72 plus 98 plus 75 divided by 3. Right?
Right.
So it will be 81.6, right?
Yeah.
Okay. Now 81.67. Now you have computed y bar naught, you have computed y bar 1. Now you have to compute sigma x. What is this? This is population standard deviation, right? Okay, in the lecture video, ma'am has used small sx, but that is not sample standard deviation. It should be, I mean, there is a mistake. It should be population standard deviation. That means you have to compute the standard deviation of these whole x observation. That means you have to compute the 98, 68, 72, 65, 98, and 75. You have to compute the x bar for whole things and then take the deviation and square. That means you have to compute the sigma x of this x variable, this numerical variable. Is that clear? Suppose, for example, sigma x is coming out to be, let's take as a 70 for the simply hypothetically. Okay. So what will be your point by serial? So point by serial will be y bar not in y bar 1. Suppose it is 77 minus 81.67 divided by 70 into square root of 0.5 into 0.5. So if you see, if you subtracted 77 minus 81.67, so it will come out to be negative. It's okay, but try to take 0 as which is in which value is in greater, or simply if in the question it is mentioned absolute point by serial, then just take the absolute value of these two. Automatically it will come out to be a positive. Okay, so from here you can compute the value of RPB, I mean point by serial. Okay, I mean just subtract it divided by these things. Okay, so your RPB will be something. So is that clear how you have to compute the point by serial correlation coefficient between one categorical variables and one numerical variable?
Could you repeat the standard deviation part?
Okay, see, standard deviation is what? Sigma of x. That means your one there you have only one numerical variable.
Yes, sir.
So you have to come see there is two, one categorical and one numerical. Then sigma x you can compute for numerical variables. Then for whole values you have to compute the population standard deviation. That's it.
So what should we take as xi?
Xi will be this whole thing, and 98, 68, 75, 98, 70.
Okay.
Okay. All 98, 62, 65, 98, 75.
Okay.
So this will be your xi. Okay. By the formula of population standard deviation, it should be 1 upon n summation of xi minus x bar square. So you have to take the x bar of whole things. Okay. After that, you have to compute the xi minus x bar whole square. I mean, normally, as usual, you have already computed the population variance or population standard deviation, right? So similarly, you have to compute the sigma x. But sigma x is this is only you can compute for the numerical variable, right? So you have to compute. Okay, is that clear for everyone?
So I got a doubt.
Yeah, yes, please.
So in this video, ma'am explained like categorical variable having only two categories is known as dichotomous. So in this lecture, you're telling it as one numerical variable and one categorical variable. So what in the place of marks we actually like, does the mark actually mean something, or can we name it categorical or numerical variable?
No, Pratiksha. See, point by serial. One second. By the point by serial correlation coefficient, we are able to know the association between one categorical variables, okay, and one numerical variable. We will compute the association between these two variables. This categorical variable will be dichotomous. That means this categorical variable will be such that where you can label one category as 0 and one category as 1. Are you getting? Suppose here our categorical variable was gender and numerical variable was marks. Okay? Gender was dichotomous. One was female, one was male. Here I have label as male, I have label. Dichotomous meaning of dichotomous, that's it.
So Prashant, the question comes basically, the question comes whether anything exists for a categorical variable having more than two values, like 0, 1, 2, 3, like satisfied, unsatisfied, something like that. Maybe 5 values.
It can be there, but for this, your categorical variable will be dichotomous. For category point by series. Suppose you are in, let's take example of tossing a coin. Okay, if you take an example of tossing a coin, so it's also a dichotomous variable. I mean, if you toss a coin, either you will get head or you will get tail, right? So you can interpret as head 1, you can interpret as tail 0. That means why I took the example of this, because there will be a gender variable where only two labeling will be possible, 0 and 1. I mean, you can label 0 as anyone, and you can label 1 as I mean, you can label female as also 1 and male as 0. Okay. So this type of categorical variable will be there, and one numerical variable will be there, and you have to find the association between this categorical variable and this numerical variable. Is that clear now, Pratiksha and Naresh?
It is.
No, it's clear. Only thing I was thinking, wondering whether anything exists for more any correlation between a categorical variable and a numerical variable, where categorical variable having more than two values.
No, that will not be. Then how you can compute? How you will apply this formula? Just tell me.
No, I'm not
That type of
saying
variable,
about this formula. Anything other than this formula exists.
other formula exists. For more than, I mean, for more than link, formula is not
Let us
for
assume
that.
I'm interested into finding out a correlation between a categorical variable having more than two values, maybe from 0 to 5,
Okay, then
and
how? Okay. Then just tell me that data set.
For example, you can take something like shoes, small, medium, and large, or some product
Small,
size
medium.
being small, medium, and large, and price on y-axis.
Right.
Price. Okay. Then you are, I mean, you are interested in knowing the association between size and price, right? Then here, okay, formula will be changed. Then we have to apply the, not aware about that formula actually.
I'm sorry to interrupt, but but
Yeah.
the whole point of this thing, I mean, the whole point of dictonymous and point biserial correlation
Yes.
is between the relationship between only two. So it's beyond the scope of this concept. Look, probably another concept in this statistics where it deals with three variables. So the point
It
of
might be there,
the
and
conversation
there
is
might
not
be,
possible
yeah,
there.
yes,
That's what we
Pratiksha,
were talking.
and there might be some different formula, Naresh and Pratiksha. Pratiksha, you are right. There might be some different formula but for finding the association between categorical and numerical, this categorical variable should be such that it take two categories. That's it. Okay. This okay. Then there might be another categorical categories like satisfied 1, very satisfied 2, extremely satisfied 3. But we are, I mean, in our course, only two things are there. Okay. So, for example, you can take like there are set of question paper like set 1, set 2, set 1. Okay. So, set 2, then our categorical is set of variables, right? Then I can interpret as 0, 1, 0, 1, and 0. Okay. Suppose this is marks of students in set 1 and set 2 respectively. So I'm interested in association to find the association between set of papers and marks of students. Then here I have to apply the point by serial, right? That is y bar naught, y bar 1 divided by sigma x into square root of p naught into p. Is that clear now? So this categorical will be variable will be such that you can label as 0 and 1. That's it. Only two labeling. Is that clear? And one more thing.
Yes.
So, if your point by serial is lies between 0.752 between 1, then I mean two variables are there. I mean two variables are strongly influenced. Otherwise, not strongly influenced. Okay. So this is sample. Okay. And one more thing, you must remember this should be population standard deviation. Do not use sample standard deviation. Okay. In lecture video, ma'am has used SX, but that was by mistake. It should be population standard deviation. Okay. And you can use sample standard deviation, but formula will get changed. How? Let me tell you. If you remember, I have told you sigma and sigma square as n minus 1 sx square. If you remember, right? So instead of sigma square, I can write n minus 1 divided by s square. Okay. So instead of sigma minus 1 into s, this thing is that clear or not?
It is. Yeah.
Okay.
No,
Now,
it's clear.
so you have to use a population standard deviation. Suppose you are, I mean, you are like to use sample standard deviation. Then instead of this value, I have to use this value. That means my formula will be kind of this square root of n minus 1 into n into s into square root of p naught into. Is this clear?
Yes.
If you are using the sample standard deviation, then you have to use this formula. Otherwise, just Simply calculate the population standard deviation of that numerical variable and y bar not minus. Okay. Most of the cases people did the mistake this one 98 plus 68 plus 65 divided by 6. No, you have to take the average of only zeros values, right, and one value. And okay, so is that clear for everyone?
Yeah.
Okay, so till week 4 we have covered I think all of the topics. Hope you got the concepts. I mean, I was able to understand. So till week 4 we have covered. So
I
now
have
if
a
you are
generic
interested,
question.
yeah, Lakshmi, please.
Like, what if now, for example, we were calculating gender and marks. Now, what if there actually, like, gender is not an influencing factor, and what if the influencing factors are something else? Availability of resources, internet, the number of hours they spend studying, and all that. And what if gender is actually not a factor, but still it appears like a factor? A linear relationship is arrived at. Then what will we do? How will we know whether the data set is like
Categorical variable. Actually, I did not get your exactly point. You are asking about how you will be able to differentiate between
like
categorical and numerical.
imagine there are
Am I
5
right?
features. Imagine that there are 5 features which are affecting marks, and 4 features are valid. They are certainly affecting marks, but 5th feature only appears like it is affecting the marks.
For example,
Now that's what I said. For example, like in case of like gender and marks, what if gender is not a factor? What if gender is not an affecting factor? The factors could very well be number of hours they spend studying, or like resources and all that.
I think the question is not related to
but I think
become
like
correlation,
conceptually,
but it's more related to data science where you want to reduce the number of variables which are basically correlated together, right? It's a basically larger concept, maybe not related directly here,
Okay.
because here we are just finding out the relations between the variables.
Yeah, relation between one categorical and one numerical. Like I have took the example of this set of the papers. Okay, suppose I'm interested in knowing the, suppose there are 2 set of papers, okay, and marks of the students. So there are 2 set of paper like set 1 and set 1 and a set 2, set 1 and set 2 and set 2. For example, these are the and marks of 6 students is there. Okay, let's take 98, 32, 29, 51, 99, and let's take 78. So I'm interested in whether this sets of the paper and marks of the students are associated or not. Okay, so here I can label as 0, 0, 1, 0, 1 and 1. Also I can label as 1, 1, 0, 1, 0 and 0. So this is something here we are where we are only interested in knowing the this association between this categorical variable or this numerical variable. That's it.
Yeah.
Not about
Yeah.
lot
So
of things.
it's just like, I think,
just a fundamental concept. Yeah, Naresh. Yeah, you are right. Just a fundamental concept for the association between one categorical and one.
Right. If you are having a single dependent variable and multiple dependent variables, you can find out the correlations between the independent variable and each individual dependent variables, and basically infer that whether it is available, it's correlated or not correlated. If it's correlated, you can remove that.
That is something beyond your, you can say, scope of this fundamental course.
Okay.
Till now it's clear for everyone, right?
Yes.
Okay, so if you are okay, then we can proceed for week 5. Otherwise, we can cover in the next session. What you
Actually,
say? Because
Prashant
you are
all
continuously doing the session
hungry,
from.
very hungry.
Yeah,
think
that's
for
why
that it's almost
I asked, because you are continuously attending the session from 4 o'clock, right?
Yeah.
4 to 6 for maths 1 and 6 to 9:30. I have bothered you guys like. So if
I
you
think
are
it will be
not
better
okay,
if
then we will
it
cover the rest of the thing
in the next session, because it will be more useful. But otherwise, slowly we will be.
Yeah. Okay.
Yeah.
So now, yeah. Okay. So meanwhile, till week 4, you got the concepts. I mean, I hope I was able
Yes,
to able to.
Could you please
Okay.
share page number 21 and 20, quality of your notepad so that I can take the screenshot?
20 and
Or
21.
can you send us the recording itself so that we can record
Yeah,
it?
recording will be there. Support will send you recording of
Okay,
this.
okay.
Yeah, but that will
Please
take
share the
time. If
entire
you could
note so
please,
that we'll be taking the screenshots in between.
yeah.
Thank you.
Okay, entire notes.
Yeah.
Okay.
Thank you,
Can I
Prashant.
get,
The lecture was amazing. I will just go and have my dinner.
Okay.
So can we get one more session in the next week or something?
Yeah, I think it's 20 on 24th of July. There might be. You will get notification and email
Yeah.
regarding that. Okay.
Yeah, sure.
Yeah.
Sure.
Okay. So who said this 20 page? This
Me,
figure or
me.
this region? This
Yeah,
region?
this page.
Okay, because I have to minimize these things. 1 second.
No, I need the figure part. Above part.
Okay, figure part only.
Yeah.
Okay. Okay, figure part. Now it's okay. Let me zoom a little bit. Yeah. Now I think it will be okay.
Figure part and the notes below the figure.
This one?
Yeah. One sec.
Yeah. Please.
Page number 21 also.
Page number 21. This things.
Yes.
Okay.
Okay.
Yeah, major thing is this. You can take the screenshot of this range. Okay, where you might know for what range, whether it will be moderate and positive, weak and positive and all things. And one important formula which I've derived the expansion of the variables. Where it was. Yeah, these things. These two things. I'm doing this blue things, and this.
Yeah, this I have taken.
So you can take, yeah, this is the important one. You can take this one, okay, which will help you on a lot of questions. So just you can take it. You took it. Should I stop?
Yes. And one more thing I want to ask. Would you suggest any source so that we can practice questions?
Source for on the portal, if you see there is mentioned a book. If you see.
No, book is not mentioned, I think.
No, book is mentioned. Course introduction, it is mentioned. Kindly go through again. Okay.
Sir,
So
and
I think.
hello.
Yes, please.
Sir,
Yes.
as a whole on the exam day, how many questions can we expect from this particular paper, sir?
I think 15 to 16 questions.
So,
Around.
no, so would that be similar for maths and other subjects as well? The number of questions of for a subject.
Actually, for different subjects, it might vary, not exact same, but it will be like that. You guys will be able to solve or solve the question paper within the time. It will be like if suppose question is 15, then you will be able to solve that 15% within the time. Okay. If otherwise, level according to level of questions, we will decide the number of questions as well. Okay, and
Okay,
time
sir.
accordingly. Okay.
Contain the questions of different types, right? Be it MCQ, numerical, or multiple select and all.
Yeah. It different types will be there.
Sir, I'm unable to find the name of the book. Could you please tell the name?
Okay, on the portal, let me search it. So there, go to in this course introduction. Okay, there is a subsection general instructions and important links.
Sir, for diploma students like us, we don't have, I think, access to that portal.
Okay, then let me, yeah, okay, 1 second then. Yeah, 1 minute, please. I'm searching.
Sure.
Yes, Lee? Yeah, there is a book, some fourth edition of by Sheldon Ambrose Introductory Statistics, 10th edition. Okay, so you can search it on Chrome or Google.
Introductory statistics by
Sheldon and Ross.
Sheldon and Ross. Okay.
And one thing and one other, introductory statistics 10th edition by Neil A. Yes.
Neil A.S.
Neil A. Yes. W-E-I-S-S. Neil N-E-I-L-A dot V-S. W-E-I-S-S.
Okay, sir.
Okay.
Okay.
Okay, then thank you everyone. Rest of the things we will cover in the session. Okay.
So we'll have only one more session, right?
Hope it will be 2 more sessions. I think.
Thank you,
Thank you, sir.
Okay.
Thank you, Prashant.
Yeah.
Thank you,
Okay.
sir.
Thank you
So-
everyone. Bye. Bye. Yeah. Yes, please.
Sir, please share the notes. Thank you.
Okay. Okay. We'll start.
Thank you, sir.
Okay. Yeah.
Thank
Okay.
you, sir.
Thank you. Thank you everyone.
Thank you, sir.
Yeah. Just go for your dinner and all. Okay. Okay. Bye. Bye everyone. Bye.